Hello everyone, a very good morning. So this is one of the most important days in your life. I understand that. So we are starting the session right away. Okay, one last revision. We'll start with chemistry and then we'll study, revise physics and then biology. Are you all excited? Are you nervous? How is the preparation? Are you confident? You have got to be confident. Alright? So don't panic, guys. It's okay. So we understand that you are, a little bit panicking. A teensy bit of panicking is fine because this is exam. You have got to panic a little bit, not too much. Okay, take deep breaths. Let's start the revision. Okay. So, and also I'll tell you one thing. You don't have to remember everything that we say now. Okay, you will remember eventually in the exam. You will have 3 hours of time. Okay. So keep yourself very, very calm. Take deep breaths and keep a transparent water bottle with you. Okay, let's get started. Hi everyone, Nanda, Raghu, Ramesh, Galpek, all of you, Vignesh. Hi. So let's get started, guys. Yeah, all right. So yeah, where is the remote? I forgot the remote. Thank you. This is not the remote, I guess. Is this a remote? Okay. So let's get started. So the first chapter we'll revise. Okay, we'll just be revising, guys. If you have any doubts, so without any hesitation, you can ask us. Let's get started. First chapter, chemical reactions and equations. So in the chemical reactions and equations, we have discussed in depth. So what are chemical reactions? What are chemical equations? First of all, indicators of chemical reaction. Okay. All right. So yes, indicators of chemical reaction. What are the indicators? Change in smell. You can answer in the chat section. Come on, quickly. Change in smell, state, change in smell, state, evolution of gas, Next, temperature change, that is heat energy is either observed or given out. Formation of a new substance, What else do we have? Are there any indicators? Other indicators, formation of precipitate. I'll write PPT, you write precipitate if they ask you in exam. Okay, these are the indicators of chemical reaction. Very good. Change in smell, state, color also, which are prominent always. Third and the fourth one, there is always a new substance that is formed and temperature change will be there. Okay, understood? Hi Tarun, hi Sudhish. Hi, very good, all of you. Next, so balanced chemical equations are those which obey the law of conservation of mass. What is law of conservation of mass? Mass is neither created nor destroyed during a chemical reaction. So atoms will be rearranged. The old bonds will be broken and new bonds will be formed. Okay, this is nothing but balanced chemical equation. So balanced chemical equations, in balanced chemical equations, LHS is equal to RHS. What is LHS? LHS is the reactant side. RHS is the product side. Very good morning, Tarun. Yes. So same number of atoms of each element on both sides of the equation. Very good, Galfix. Super. I guess your name is Aryan. Yeah. So types of chemical reactions. We have different types of reactions. Combination reaction we have. We have studied about decomposition reactions. Combination reaction is opposite to that of decomposition reaction. And then we have single displacement or displacement reaction. So the more reactive metal is going to displace the less reactive metal. And then we have double displacement reaction, guys. Double displacement reaction. And then we have redox reaction. What is it? Redox reaction. Okay. Revising everything, right? Yes. Mass cannot be created nor destroyed. Very good. Galfic. Yes. Combination, decomposition, displacement or single replacement. Yes. Double displacement reaction and redox reaction. Combustion reaction is there in carbon and its compounds. Okay. Nanda, it's okay. Take deep breaths. Breathe in and breathe out. Take deep breaths. Keep yourself very, very calm. Try to keep yourself very calm. And all of you, please do have your breakfast and go. Okay. Please do have your breakfast and go. Yeah, we'll discuss isomerism. Okay. Yeah. So we'll discuss redox reaction as well. Yeah, combination reaction is nothing but, so where reactants, so two or more reactants combine to form a single product. Reactants combine to form a single product. Combine to form a single product. This is combination reaction, guys. And you need to be able to give the examples here. Okay. So calcium is going to react with oxygen to form calcium oxide. And always make sure to balance the reactions. Decomposition reaction is opposite to that of Pradeep. Session duration will be around 1.5 hours. That's it. Half an hour for chemistry. I'll try to finish up everything within half an hour. Max to max 35 minutes, 40 minutes. Okay, physics same. Alright, yes, we'll discuss everything. Yes, decomposition reaction is opposite to that of combination reaction. Here, a single reactant breaks up to give two or more products. And decomposition reaction are of three types. Thermal decomposition reaction, photolytic and electrolytic. Photolytic and electrolytic. So amongst these, electrolytic decomposition of water is extremely important. 2H2O is going to decompose to give 2H2 and O2. Okay, this is so decomposition reaction. So electricity will be passed. Electricity will be passed. Photolytic. So in presence of sunlight or ultraviolet light, certain substances, chemical compounds are going to break down to give so two or more products, respective products. It's nothing but yes, photolytic. Thermal. So we have so many examples. Calcium carbonate, when it is heated, it is going to form calcium oxide and carbon dioxide gas. Okay. What is this? The process of simplifying a single chemical entity into two or more fragments. Galfic, this is quite difficult, but you can use simple words. Very good. Yes. So displacement reaction. What is displacement reaction? The more reactive metal. So who is this? Ratna. More reactive metal is going to displace the less reactive metal. That is displacement reaction. Displace less reactive metal from its salt solution is called displacement reaction. Okay, in order to remember displacement reaction, we need to remember the reactivity series. Okay, in the reactivity series, the metal that is placed above can displace the metal that is placed below, not the vice versa one. Okay, very good, Tarun, very good. Yes, moving on to double displacement reaction, exchange of ions is going to happen. Exchange of ions. Okay, so here not all double displacement reactions leads to the formation of a precipitate. They might ask you this question. So are all double displacement reactions precipitation reactions? No is the answer. Okay, not all double displacement reactions are precipitation reactions. Okay, very good morning, Santosh. Yes, redox reactions. So both oxidation and reduction. Guys, see here, some of you asked me to explain redox reaction, right? Yes. So oxidation and reduction occur simultaneously in a reaction. So that is nothing but redox reaction, guys. Example, copper oxide will undergo redox reaction in presence of hydrogen. So it is going to give copper and H2O. See here, copper oxide has become copper, which means that it is undergoing reduction, while H2 to H2O. So what is this? Oxidation. In the same reaction, both oxidation and reduction are occurring. Okay. Yes. And what are reducing agents? Yes. Shubham, after chemistry, Neha ma'am is going to take physics. Okay, she is right there. Yes. What are the conditions for double displacement reaction? There are no conditions, Monishri. Okay, there are no conditions. Yes. Chemical reaction in which electrons are transferred between two reactants participating it. Very good, very good. Awesome. Yes. Tell me, what are reducing agents and oxidizing agents? Reducing agents are those which are going to undergo oxidation, reducing the other. Okay, so which is the reducing agent here? See here, so H2 is the reducing agent. Okay, because it is itself undergoing oxidation. Okay, it is itself undergoing oxidation. That's why it is the reducing agent. Which undergoes reduction is the oxidizing agent. Okay. Hi Piyush. Very good morning. Very good morning. Yes. So rancidity and corrosion. So rancidity is nothing but it happens in case of food containing oils and fats. Foods containing oils and fats. Okay. So they undergo redox reaction. Okay, to form a very bad smell as well as odor. The rancid food items are unfit for human consumption. We cannot consume rancid food items. How we can prevent rancidity? So packing them properly, refrigerating them, using airtight containers, using antioxidants like nitrogen gas. Okay, so that's how we prevent rancidity. Next, prevent corrosion and its equation. Yes, explain 1 minute extraction of metal. Yeah, extraction of metal will be discussed in the chapter metals and non-metals. Just give me 10 minutes. So corrosion, sit throughout the session. Ratna, is it Lalit, sit throughout the session. This is very important. You can sleep after your exam. Yeah, so corrosion. So this happens in case of metals, only few of the metals. Okay, corrosion in case of iron, it is called rusting. Corrosion in case of copper and silver, it is called tarnishing. Copper and silver, it is called tarnishing. Tarnishing. Okay. So, in case of iron, hydrated ferric oxide is formed. Okay. Yes. Copper and silver. So, in case of copper, it is hydrated copper carbonate. Okay. Or basic copper carbonate is responsible for tarnishing of copper, and Ag it is H2S. Silver sulfide is responsible for the black color of the silver. Okay. Lalit, okay, we'll discuss extraction. Yes, damage of the metal. Damage or deterioration of metal. It is a natural process where the metal surface is deteriorated. Okay, that is corrosion. Moving on, acids, bases and salts. We are done with first chapter, guys. It's only been 10 minutes. So next, neutralization reaction. Acids are going to react with bases to form salts. The respective salt, water and some amount of heat energy is released. This is an exothermic reaction. Yes, we have discussed about exothermic and endothermic reactions. So this is neutralization reaction. So here acidic salt can be formed, basic salt, basic or neutral salts can be formed depending upon the strength of the acid and the base. Next, if we talk about chemical properties of acids, what are the chemical properties of acids? Yes, how acids are going to react with metals. So the metals that are placed above hydrogen, the reactivity series can react with acids. Okay, displacement reaction happens here. Respective salt is formed along with hydrogen gas is formed. So hydrogen gas, confirmatory test is, so it burns with a pop sound. So meanwhile, we have discussed about acids reacting with metal carbonates or bicarbonates to produce carbon dioxide gas. Carbonates or bicarbonates, to form what? To form carbon dioxide gas, salt and water. So confirmatory test for carbon dioxide. So passing through lime water, calcium hydroxide. What are we going to get? Calcium carbonate, which is the precipitate. Okay, are you following me? Yes, damage of the metal, very good. An acid react to form water, and salt involves combination of H plus ions and OH minus ions to generate water. Yes. Reaction between acid and base to give salt and water. Very good, very good. Piyush, Vignesh, Galfic, all of you. Keep it up. And if we discuss pH scale, and are they bases are going to react with metals or not? No, they are not usually going to react with metals, but there are amphoteric metals, guys. Remember this. Amphoteric metals or metal oxides are those metals which are both acidic as well as basic in nature. That's why they can react with both acids as well as bases. Okay. The extent to which it ionizes when dissolved in water, that is the strength of acids and bases. Next, pH scale. So when it comes to pH scale, they might ask you to explain pH scale. pH scale is nothing but power of hydrogen. pH scale, pH is inversely proportional to the concentration of H plus ions. As the concentration of H plus ions increases, the pH decreases. Okay, and vice versa. So pH is nothing but potence or power of hydrogen. It varies from 0 to 14. Okay, below 7. So if the pH is below 7, H plus ion concentration is more, which means that it is acidic in nature, and vice versa. Above 7, so the concentration of OH minus ions will be more, so it will be basic in nature. So 7 means neutral. pH 7 is equal to neutral, and we have discussed about universal indicator. Okay, yes, biology will be discussed at last. Okay, maybe after 6:30. All right, to check. Yes, pH scale is used to identify the acidity and basicity of a particular substance. Yes, all right. So moving on to strength of acids and bases, we have strong acids and strong bases, guys. Strong acids and bases are those which are going to completely furnish, completely ionize or dissociate in water. Okay, weak acids or weak bases are those substances which are going to partially ionize or dissociate in water. They are called weak bases or weak acids. It depends. If they ask you to describe strong acids, mention like this: acids, the acids which are going to completely furnish to give H plus ions in water are called strong acids. Understood? All right. So a scale of measuring H plus ion. Very good, Santosh. Very good. Keep it up. So now moving on to NaOH. Preparation of salts. Super important. So this is chloralkali process. Chloralkali process, where concentrated, highly concentrated aqueous solution of sodium chloride is taken and it will be electrolyzed. It will be electrolyzed to give caustic soda, that is NaOH, and will get chlorine gas and hydrogen gas. All of these are useful. Okay, all of these are useful. NaOH is used in manufacturing of fibers, and will make that make use in soap industries, factories, and also degreasing of metals. Hydrogen is an excellent fuel. It is used in hydrogenation of vegetable oil into vanaspati, and chlorine gas is a very good disinfectant. It is used in the manufacturing of CFCs, preparation of PVC, polyvinyl chloride. Okay, very good, Monishri. Yes, all of you, very good. Keep it up. Next, we have bleaching powder. So bleaching powder is nothing but calcium hypochlorite. When the chlorine gas is passed over dry slake lime, calcium hydroxide, it is going to, yes, let me rub this off. I don't want you to get confused. Yes, CH twice gives CaOCl2. And what else are we going to get? H2, I guess. Right? H2O. Yes, H2O. So this is calcium hypochlorite or bleaching powder. What are the uses of bleaching powder? So bleaching powder is used as a disinfectant. Okay. Hi, Ritishram. Yes, good morning. Very good morning. Very good morning. Yes, we'll explain universal indicator here. Okay. So universal indicator, it shows array of colors. Universal indicator. So it is a synthetic indicator. It is a mixture of several indicators. Okay, how is it going to distinguish between acid and bases? So it is going to show an array of colors, different range of colors, array of colors. Okay, so if the substance, when we add universal indicator to substance and it shows green color, it means that it is neutral. Green color, neutral. Okay, so red acid, it is dark purple, then it is a strong base. So it shows a wide array of colors. So from green to purple, okay, that is basic substance. Okay, the colors indicate basic substance. And from green to red. So how is it going to change? Green, yellowish green, orange, yellowish orange, orange, yellow, orange red, dark red. That's how it's going to show. Okay. 2NaCl plus 2H2O gives 2NaOH plus Cl2 plus H2. So which is that? This one. Is it not balanced? Yeah, it's not balanced. Thank you. So yeah, you need to write the balanced chemical equation. Okay. So used as an oxidizing agent. Which is used as oxidizing agent? Bleaching powder is used as oxidizing agent. Very good. Hi everyone. Hi. some questions paper they gave acid, orange. Yeah, they could give. Okay, so yeah, the array of colors ranging from green to red. Okay, it might be orange red, yellowish red. Okay, all those colors, greenish yellow, those indicate acidic substance. Next, baking soda. So how are we going to prepare baking soda? We'll take brine solution, guys. Okay, and we'll introduce this into a carbonating tower and make all these things react with ammonia to give what are we going to get? NaHCO3. This is baking soda, sodium bicarbonate, and NH4Cl is the byproduct, ammonium chloride. Okay, baking soda, what are the uses? These are used in is it necessary to write physical states? So if you know the physical states, write it. Okay, it's not the time for you to start looking for physical states. Only if you know, write the physical states. And I'll tell you one thing, if there are metals, okay, except mercury, most of the metals will be in their solid state. If it is a metal, there is a reaction. Okay, yes. Now moving forward, baking soda uses, it is used in soda acid fire extinguisher. It is used in making baking powder. So baking powder is nothing but baking soda, mixture of baking powder, baking soda, and a mild edible acid like tartaric acid. Okay, all right. Next, washing soda, recrystallization of this heating NaHCO3 gives us Na2CO3. Please write the balance equations, guys. Okay, NaHCO3 leads to Na2CO3. We have to do this. And what else? Carbon dioxide gas will be released. 3 2 is 6. And what else? What else do we have? H2O. Okay. And recrystallization of this Na2CO3 is made to react with water. So we'll get Na2CO3, 10H2O. What is that, guys? 10H2O. What is that? This is nothing but washing soda. Okay. So it is nothing but washing soda. Makes the cake soft. Very good, Ritrishram. Very good. Yes, Prakhar, biology ma'am will come and explain that. Okay. Arun, why are you tensed? If you have studied properly, you don't have to get tensed. Okay. Breathe in and breathe out. Okay. Pray to your favorite God. Okay. And get the blessings of your parents or elders. All right. Yeah. So POP, plaster of Paris, is nothing but calcium sulfate hemihydrate. So it is used in making sculpture, toys. It is used as a fire resistant, okay, in fireproofing the buildings. And also, POP, plaster of Paris, is used in casting of the fractured bones. Okay, water of recrystallization. Yes, very good, very good. So 10 molecules of water of recrystallization is there. Okay, water of crystallization. Yes, that is 10 molecules. In copper sulfate, that is blue vitriol, 5 molecules of water of crystallization will be there. Okay, that's why. So water of crystallization gives a specific crystalline structure, and also it gives imparts the specific color to the compound. Okay, so final tips for science by all teachers. Absolutely will do that. All right. So now moving on to the next concept. Yeah, POP, gypsum. You need to remember gypsum, calcium sulfate dihydrate. When gypsum is heated, so it is going to give calcium sulfate hemihydrate. Okay, calcium sulfate hemihydrate. Okay, so I'm sweating actually because of the tension. Next, we'll move on to metals and non-metals. So from metals and non-metals, you will have a lot of questions. So remember the physical and chemical properties of metals and non-metals properly. Okay, physical properties. Which are the physical properties? I'm not going to go in deep about this. Ductility, malleability, conductivity, and what else do we have? The lustrous nature of metals. Okay, and ductility, malleability, sonority of the metals. These are the physical properties of metals. Okay, they might ask you to differentiate between physical properties of metals and non-metals. All right, next, chemical properties of metals. Metals are going to react with water. So which metals? The metals that are placed above hydrogen in the reactivity series, only those are going to react with water. Okay, to form metal oxide and hydrogen gas. Metal oxide is going to react with water to give metal hydroxide, and metal is going to react with dilute acid to form salt and hydrogen gas. So this is something that we have studied in first chapter itself. So how different metals are going to react with water? So potassium, sodium, these are highly reactive metals. They are going to react with cold water itself. There is a very vigorous reaction. Okay, and then magnesium, so it reacts with hot water. Calcium reacts slowly with cold water but very vigorously with hot water. And aluminum, calcium starts floating. Okay, and aluminum reacts with water vapor, that is steam, and iron reacts with steam, zinc reacts with steam, copper, silver, gold, these are not going to react with water at all, not even with steam. Okay, very good Tarun, very good. Arun, koi solution? See, do not panic. That's what I'm telling you, bacha. Okay, do not panic. It is okay. Okay, you have your exam. You will get done with the exam by lunchtime. Okay, just hold your confidence as of now. Okay, you have studied, right? I have seen you multiple times in my class. Okay, you have studied. You have given really good answers in the classes. I have confidence on you. Okay, so if you lose confidence now, you're going to panic in the exam and you can't remember anything that you have studied throughout the year. Do you want that to happen? No, right? So keep yourself calm, okay, and pray to the God. Hope that it's going to be okay. Okay, and also we're all going to pray for all of you. Okay, we all are going to, so keep you in our prayers today. All right. Yes. Chemical properties. All right, aluminium, iron, zinc reacts with steam. Very good, Tarun. Yes. Next, what else? Yes, this is the reactivity series, guys. Remember this: potassium, sodium, calcium, magnesium, aluminium. These are the most reactive metals. Zinc, iron, lead. These are the moderately reactive metals. Then we have hydrogen, copper, and mercury. Less reactive metals. Silver, gold, and platinum. Least reactive metals. Okay. And metallurgy. Okay. So this is the flow chart, guys. I'll explain this. Okay. So this is metallurgy flow chart. So first concentration of ore will be done in order to remove impurities, remove gangue particles or impurities. Okay, then we are going to take the ore. Okay, then we are going to obtain the ore. So metals with high reactivity, they cannot be reduced just by heating. That's why we are going to do electrolysis of the molten ore. Okay, electrolysis of the molten ore. So pure metal will be obtained. How do we do electrolysis? We are going to take the molten ore of the particular metal. So we are going to fix anode and cathode. At the cathode, reduction is going to happen. At the anode, oxidation is going to happen. At the cathode, metal is going to get deposited, is going to get reduced. Remember this, cathode reduction. Metal is going to get reduced. At the anode, so whatever that is, so NaCl, if we take NaCl, chlorine gas will be released. Or if you take, calcium oxide, oxygen gas will be, released. Okay, depends on the ore. All right. So now moving on. Next, metals with medium reactivity. So if it is carbonated ore, we'll do the process calcination. Calcination is nothing but heating the ore in limited supply of oxygen, guys. Limited supply of oxygen. Okay, it is done for carbonated ore, and for sulfide ore, we'll conduct the process called roasting. So we'll get the oxide of the metal. We will be reducing this metal using reducing agents, guys. Reducing agents needs to be used for moderately reactive metals like hydrogen or coke. Coke is the best reducing agent because it is inexpensive and very effective. Okay. Yes. Next, what do we have? Metals with low reactivity, and metals with least reactivity, they are found in their native or pure form, as they are not going to react. So metals with very less reactivity, metals with very less reactivity like silver, gold, platinum, they are going to be found in their native or pure form. You don't have to worry about them. Okay, so metals with low reactivity, so sulfide ores are carbonated ores, we are going to conduct roasting. Okay, for sulfide ores, or calcination for carbonated ores, will get metal oxide. It will be heated to it will be heated to produce the metal, and refining process will be conducted after this. So what is refining? I'll explain this using copper itself. This is refining, guys. This is one of the most frequently asked questions for you. Okay, so yes, this is a source of the energy. Okay, we'll take an electrolyte here. This is electrolyte. One is anode, one is cathode. One is anode, one is cathode. So at cathode, reduction is going to happen. Okay, and the anode, oxidation is going to happen. Okay, oxidation is going to happen. So at the anode, we'll take impure metal, and at cathode, we are going to take pure metal, pure slab of the metal. So electrolyte, so if it is copper, okay, if you are refining copper, we'll take copper sulfate. Acidified copper sulfate will be taken as the electrolyte. Okay, and we'll get some impurities at the bottom. Okay, always make sure to write the diagrams, even if it's chemistry, physics, biology, in pencil. Do not use pens, guys. Okay, yes, so this is anode mud. Okay, these are the impurities. When we pass electricity through electrolyte, so the metal ions from the anode are going to come to the electrolyte, and the ions that are already present in the electrolyte are going to get reduced on cathode. So the size of the cathode increases. Size increases. Which cathode? Okay, size of the anode decreases. Okay, understood? Remembered everything? Okay, ionic compounds are formed because of complete transfer of electrons. Transfer of electrons. Metals have the tendency to give electrons, donate electrons, and they form cations. Okay, they form cations. Cations are nothing but positively charged ions, and non-metals have the tendency to gain electrons. Non-metals have the tendency to gain electrons, and they are going to form anions, negatively charged ions. Okay, so these, this leads to the formation of a bond called ionic bond, and the compounds are called ionic compounds. And what are the properties of ionic compounds, guys? Yes, what are the properties? They have high melting and boiling point. High melting and boiling point. And what else? Ionic compounds, they are soluble in water. Soluble in water. They are present as solids at room temperature. Solids, they usually are solids at room temperature, and they are good conductors of heat and electricity in molten and aqueous form. Molten and aqueous form. Okay, so this is about ionic compounds, properties of ionic compounds. Moving on to the last chapter, guys. We'll be discussing this in 5 or 7 minutes, 5 to 7 minutes. Covalent compounds are formed when sharing of electron happens. Sharing of electron happens, covalent compounds. Okay, so covalent compounds are usually insoluble in water, and covalent compounds are bad conductors of electricity. They might ask you to differentiate between ionic compounds and covalent compounds. Very good, very good. Yes, and then sharing of electron leads to covalent compounds. And what else do we have? Carbon, is tetravalent in nature. It cannot lose or gain electrons. It is going to share electrons. And we have single covalent bond, double covalent bond, and triple covalent bond. And then we have electron dot structure. Electron dot structure. Okay, representing electrons. Which electrons? Valence electrons using dots or into mark. Okay, next, hydrocarbons. So what are hydrocarbons? The compounds containing hydrogen and carbon only. Compounds containing hydrogen and carbon only. These are called hydrocarbons. Okay, hydrocarbon derivatives. If one of the hydrogen is replaced by heteroatom, so it is called hydrocarbon derivative. And homologous series. Homologous series are series of compounds containing same functional group. They have same, chemical properties. Okay, the adjacent homologs differ by CH2 unit. CH2 unit, or in other words, 14 atomic mass unit. These are homologous series. Okay. Yes, very good, Galfik, very good. So moving on, functional groups. So we have alcohol functional group, guys. Alcohol, ROH. Then we have aldehyde functional group, RCOH. And then we have ketone, RCOR dash. Okay, then we have carboxylic acids. Carboxylic acids, it is RCOOH. And then we have ketone, RCOOR dash. And then we have RX. What is RX? Not the bike. RX 100. No, not that. X is any halogen. Halogen. Okay. Group 17 element. So these are the functional groups. Functional groups are those heteroatoms which which give specific chemical properties to the, carbon compound. Okay. So Ritishram, you can revisit us, okay, and we'll be conducting fun sessions during your vacations. Okay, you can join us. Yes. So IUPAC nomenclature consists of prefix and parent name, or yes, we'll write parent name or root word, parent name and suffix. So back, yes, single bond alkanes, it's called alkanes. If there is carbon-carbon double bond, it is called alkenes. And if there is carbon-carbon triple bond, it's called alkynes. And the general formula, I'll write it here. Okay, for alkenes, it is CnH2n plus 2. For alkenes, it is CnH2n. For alkynes, it is CnH2n minus 2. Okay, this is the general formula. Remember this. Next, so prefix is only there for, halogen derivatives. Halogens as functional group. For no other functional group there is prefix. Parent name will be depending upon the number of carbon atoms. If it is 1 met, 2 eth, 3 prop, 4 but. Okay. Next we have suffix. Primary suffix and secondary suffix will be there. It depends on primary suffix, depends upon the alkane, alkyne, alkynes. Okay. And secondary suffix depend upon the functional group. It is the alcohol, it is all, aldehyde, al, all. Next we have ketone, 1, oic acid. Okay. So this is about IUPAC nomenclature. Esterification reaction is very, very important. Yes, who is the other maths teacher coming for maths exam? Nobody. It's just Suhas sir. We don't have any maths teacher as of now. Ethylene structure. So now esterification reaction, this is a super important. Okay, super important reaction. So what is going to happen? Ester is formed. How? So this is a reaction that is there. CH2H5OH, this is ethanol. It is going to react with CH3COOH, that is acetic acid. Okay, to form what? So in presence of concentrated H2SO4 acts as a dehydrating agent. It's going to form C2H5COOCH3. This is an ester. Okay, it is a sweet smelling substance along with water. Okay, this is esterification process. Esterification. Okay. Next, what is it? Rajiv. Okay. Yes. Okay, Rajiv, all the best for the exam. All of you, all the best for the exam. Next, saponification process. It is the process of preparation of soap, is nothing but saponification. So we'll take, what will we take here? Usually C2H5. So this is the reaction that's there in your syllabus, not HCH3. Okay. So we are going to take this and we are going to make it react with NaOH to form CH3COO, Na, and alcohol will be the byproduct. This is nothing but soap. Okay, sodium salt of carboxylic acid, long chain fatty acid, sodium salt of ethanoate. Okay, yes, sodium ethanoate or sodium salt of carboxylic acid. You can write that. Okay, write the structure of ester. We'll write it. Just give me a second. See here, this is ester. This is ester. Okay. Next, addition reaction. So only unsaturated hydrocarbons are undergoing addition reaction. Unsaturated hydrocarbons will be undergoing addition reaction. Here hydrogenation reaction is very important. Addition of hydrogen in presence of nickel or palladium catalyst. So for example, CH2 double bond CH2, when we add hydrogen in presence of nickel or palladium catalyst, it's going to give us CH3 and CH3. Unsaturation is removed. Substitution reaction is possible for saturated hydrocarbons. So we have seen chlorination in presence of sunlight, CH4 plus Cl2. So in presence of sunlight, what's going to happen? CH3Cl, substitute. One of the hydrogen atoms is going to get substituted. Okay, CH3Cl plus HCl. Next, cleansing action of soap. Guys, micelle formation is very important. This is the last question. Okay, don't worry. We are done with chemistry syllabus. Yeah, it's only 6:10. Yeah. So, moving on, cleansing action of soap, micelle formation. Micelle formation. So, soap will have this structure. This is the hydrophilic end or the ionic end. Okay, Na plus or K plus. This is the carbonyl group, carbonyl end. Okay, so this is hydrophobic in nature. This is hydrophobic in nature. So when there is a dirt molecule, so this is how it looks like. Okay, this is how it looks like. This is nothing but micelle. Okay, as hydrophilic end, so is is going to love water. It is going to push it away from the dirt molecule, while hydrophobic end, as it hates water, it is going to go towards the oil or dirt molecule and surround it. So all the soap molecules are going to do this, leading to the formation of micelle. When we rinse the clothes with water, so along with the dirt, micelle is going to get washed away. This is how cleansing action of soap works, and soaps are not effective in hard water because they are going to react with the ions that are present in the hard water. Okay, so yes, in the hard water, that is why soaps are not effective in hard water. Okay, they are effective in only in soft water, but detergents are effective in hard water because they are not going to react with the ions that are present in the detergents. Understood? All right. This is it. Let's start with physics. Okay. Now, yes, physics.
So, yeah, hey students, done with chemistry. Hello everyone. Solenoid, okay. Then, hello everyone. So, shall we start? Physics. Okay. Complete. Solenoid, everything I'll be telling, okay? Don't worry. Don't worry about that. Just a second. So, let's start now physics. Yeah. Just a second, guys. I'll just fix this up. Yeah. Okay. Solenoid. Good morning. Yeah. So desperate to study that you're not wishing me good morning. Okay. No worries. That's important, right? Your exam. Fine. Yeah. Wait. Let me start with light. Okay. I'll be starting with light, human eye, then electricity and magnetism. I'm good. How is your preparation, everybody? Yeah? You're new. Welcome to the channel. So today you have your exams, so study well. We are revising for you, right? So I have brought most important concepts. Yeah, very good morning. Okay, important concepts that may come in your paper, right? Yeah. Okay, done. Solenoid, done. Done. Okay, great. Let's enter. Let's be quick. This is not a explanation session. This is a quick revision session. So let it be as a revision. Okay. Yeah. Just stay with this. Quickly, I'll just recall all the things. So starting with components of spherical mirror. You may ask me, ma'am, it starts from reflection, refraction, but these are the normal concepts you already know. Again, no need of telling those concepts, right? But you can just remember the properties of mirror. Okay, properties of image formed by mirror, because they are hi, good morning. Okay, see, listen, properties of image formation by plane mirror. So just remember the points such as u is equals to v, image distance is equals to object distance, height of image, nothing but size of image is equal to size of object, and what is that? Upright, it is erect images, right? erect image, virtual image. Yes, virtual, laterally inverted. These points are important. Just remember this, right? Laterally inverted. Okay, I'm not going to write it again. Clear? So they are important. Hello everyone. Hello Tarun, Sundar, and yeah, everyone. Okay. Yeah, good morning and hello. Clear? They are the properties of image. It may come for 2 marks, so just I recalled it. Coming towards the components of spherical mirror, this is an extremely important concept. So I hope you all remember this, right? So what is the center of curvature? Center of curvature is nothing but the center of the sphere from which mirror is taken out, right? So this is center of curvature. What is radius of curvature? The distance between center of curvature or pole. You can state it like that, or else you can also say it as the radius of the sphere from which mirror is taken out. Clear? That is radius of curvature. Then comes aperture. Aperture is nothing but the entire reflecting surface. Entire reflecting surface is called as aperture, and the midpoint on the aperture is called as pole. Clear? The line passing through center of curvature and pole is called as principal axis. Yeah. Morning, good morning. Right? So see, just with this one rough diagram, I have explained this all the concept. So you also should remember it like this. Yeah. Good morning, young and energetic Physiotron army. This is your physics master teacher, Neha ma'am. I was also so excited to teach you guys that I didn't introduce myself. Yeah, yes. Hello, my dear young and energetic Physiotron army. A very warm welcome to Diksha Vedantu YouTube channel. I am your master teacher, Neha ma'am. Going towards the next concept, image formation in spherical mirrors. Right, how image is formed in spherical mirrors. The ray diagrams are important, or else they may ask the position, or they may ask the size, virtual or real image. These kind of question may arise from this. So I have brought this one. See, I have explained this with the trick also, right? First object will be at infinity. Then you bring little forward, that is beyond 2f, right? Beyond 2f, then at 2f, right? Sorry, at 2f doesn't exist here. Just a second. Let me cover here. Yes. Yeah. Yes. Yeah, listen. First is infinity, then beyond C, that is 2, then at C, between C and F, and at F. I told you to mark these points, right? So this is focus, this is center of curvature, and infinity, this is pole. So first object is at infinity, then beyond C, then at C, between C and F, at F, between pole. By this diagram, okay, by this ray of light, you can remember where are the position of object. Just remember the position of object, then write here in the inverse order. 5, 4, 3, 2, 1. So you'll get where image is formed. Yeah. He was having the Hindi class, so sir went fast. Yes. Yeah, refractive index, everything I'll be explaining. See here, that is important. So where is the object and where is image formed? This is a exception condition when object is very near to the mirror, image is formed behind the mirror. Okay? Yes. So point sized, diminished, same size, enlarged, highly enlarged. These are the size of image. All are real and inverted only except this last exception condition. Is that clear to everyone? Tell me, understanding? So when infinity at focus between pole and infinity, right? Between pole and infinity, here you will be always getting diminished image, virtual and direct image, as it is a diverging mirror, convex mirror, right? Yeah. Okay. You messaged that he came to... Oh, you told them. Okay, understanding? Good, 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 great. Okay, so when the object is between infinity and pole, image is formed between pole and focus. Is this clear? Yeah. Moving forward to mirror formula, magnification formula, important because we can expect a numerical from here, right? So those who have not, yesterday I have shared the formula list. Yes, Tarun, you were asking me about, ma'am, make one list of formulas, and I have shared it in the Telegram channel. I hope you got it. Okay, who have not checked it, you can go and check that quickly. So when you are going to your exam hall, you can just scroll at that formula instead of scrolling. Yeah, you can just check out that formulas. So magnification of mirror, magnification mirror gives minus, yes, that is negative. So magnification of mirror is negative. Okay, see, these are important things. So I am explaining, right? So yeah, what is the mirror formula? Mirror formula is 1 by V plus 1 by U is equals to 1 by F. Clear that? Clear with these things? So be careful, these are important numerical question. It may go from 3 to 5 marks question. So it's important. Got it? Good, 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 good. Chemistry is done now. After physics, bio ma'am will be coming here. Okay, she'll be taking the class. Moving towards the lens formula. Image formed by lens. Okay, image formed by lens. Again, infinity beyond 2f. So I was telling that 2f, right? There it was, we used to say here C, but here in the lens we'll say it as 2f. Clear everyone? Beyond 2f, at 2f, between f1 and 2f, clear. And then this is the sixth condition. Okay, this is 4 and this is 5. This is sixth condition, again an exception. Clear. Okay, so again just inverted 5, 4, 3, 2, 1. Yeah, so you'll get the image position. Very easy trick. If you get confused where the image should be formed, you can just use this table trick, right? Paper will not be completely tough, will not be completely easy, right? I have already said it. Some level will be easy, some level will be medium, and some difficult. Very little will be difficult. Yeah. Before we are going fastly, okay? So point sized image, diminished image, same size, again the same concept. So I am making this easy to remember. Very similar to this is, there it was concave mirror, but here it is convex lens. Convex lens, all are real and inverted except the last condition where object is very near to the lens. Okay, and here it is concave lens. Concave lens is similar with convex mirror, right? It will be, yeah, between easy and average paper. Right. Yes, exactly. Okay, if any one question, two question is extremely difficult, if you are unable to attend it, don't get distracted. Oh, I can't attend that. Okay, leave that. Whatever you know, first attend it very neatly, right? Yeah, infinity, focus. Always we know this, right? And also you must be knowing to how to draw the ray diagrams that I have already explained in the sessions. When the object is between infinity and optic center, focus and optic center, object is placed between focus and optic center. I have explained this trick in the separate video completely, how to remember that ray diagram video. It may be around some 15-20 minutes. You can, if you want, you can go and check out it. So diminished, always diminished image, virtual and erect are the formation of image in concave lens. Yeah. It's 6:30, so within 7:30 we'll finish it off everything. Okay. Yeah. Lens formula and magnification. Lens formula and magnification important. This is the lens formula. Mirror formula comes first, so it is positive. Lens formula comes second, so it is negative. But magnification over here is positive. Magnification is positive. Is that clear? Is that clear? Yeah, I hope that's clear, right? So magnification is nothing but height of image by height of object, which is equals to image distance by object distance. This is the magnification formula. Clear? Yeah, before moving to defects of vision, you guys were asking me about the refractive index, right? So yeah, refractive index. Yes, let me write it down quickly. So what is refractive index? It's the ratio of speed of light in vacuum by speed of light in medium. This is nothing but the formula to calculate refractive index. Clear with this? This is called absolute refractive index. If you want to calculate relative refractive index, it will be N12 is equals to V1 by V2. These kind of question. Or else another formula for refractive index is N is equals to sine of angle of incidence by sine of angle of refraction. Okay, these are the three formulas for refractive index. Is that clear? Is refractive index clear? Yes, I hope that's clear. So done with light. Any doubts from light chapter? Quickly. Done with light, moving forward with the human eye. Yes, tell me. Done? I hope that everything is clear. Moving towards the human eye. In human eye, defects of vision is important, right? And also parts of human eye. I hope you can study that. Yes, it depends. It is with respect to what? It depends. Clear? So yes, in this morning session, Ankita ma'am, Navya ma'am and me, we are handling this. Evening, all the teachers will be joining us to solve the paper, right? Clear. Then, moving forward to the defects of vision. Okay, moving forward to the defects of vision. So, what are the defects of vision? Myopia, hypermetropia, presbyopia and cataract. I hope astigmatism is not there, right? Clear? Okay, what is myopia? Myopia, short name suggests that nearsightedness. Yes guys, concentrate, you have to go to your exams. Be in that mode, in that zone, okay? Come here. So yeah, myopia is nearsightedness. Nearsightedness means you can see the near objects but not far objects. Why? Focal length is less, elongation of eyeball. Yeah, these are the reasons. These questions are extremely important, okay? In this session, I am going to discuss the important topics. So don't miss this out anywhere, right? Myopia, nearsightedness, focal length is less, eyeball is elongated. You can see near objects but not far objects. It can be corrected by, focal length has to be increased, so it can be corrected by concave lens. Clear? Clear? Hypermetropia, as the long name suggests, you can see the far distance but not near objects clearly. Hence the focal length here is more, but the eyeball is small. Eyeball is small. Focal length is more. We have to bring it near. So we will be using convex lens over there here. Right? Tell me quickly, revising, right? So before going to exam, you should be ready with this. Clear? Yeah. Next is presbyopia. Presbyopia is caused due to old age, right? Due to weakening of ciliary muscles. When ciliary muscles weakens, they will be not able to focus because they cannot adjust the focal length, increase and decrease, right? It cannot be done. Focal length cannot be adjusted. So the person suffering with presbyopia will feel difficulty. Yes, you're getting great. People suffering with presbyopia will be having difficulty to see both far and near objects. So we use here bifocal lens, right? Two lenses, both lenses are used here, bifocal lens. Clear? Astigmatism, grid-like structure will be appearing distorted. To correct it, you will be using cylindrical lens. And what is cataract? Cataract is nothing but if there is milky or cloudiness over the eye, that defect is called as cataract. There may be partial loss of vision or completely loss of vision. So how it can be corrected? Only by cataract surgery. Defects of vision, done. Moving towards the colorful word concepts. Dispersion of white light. When white light enters the prism, it undergoes dispersion and 7 colors. BIGGGG series we can see, right? So that is dispersion of white light. When white light incidents on a prism, it splits in white light into band of colors. Clear? Dispersion. From the process of dispersion, what are the example, what are the application? We can see rainbow formation. Yes, we can see rainbow formation. How rainbow is formed? When the sunlight, welcome. When the sunlight enters the water drops present in the atmosphere, the water droplets acts as the tiny particles, right? Tiny prisms. Okay, it scatters, it disperses the light into 7 colors and we can see the, right, rainbow. Yeah, I'm super duper excited to, Which one diagram? Yeah, I'm teaching, right? Nothing, very easy. Just take the prism, draw the prism, show here white light. Okay, these you can just make the band of colors with only white pencil. Sorry, with only pencil. And yeah, which color bends the most? It is violet. Which color bends the least? It is red. Mark those points also. They are important. Yeah. Bio ma'am will be coming after this, okay? That is used. Ma'am, please tell about Newton. Okay, Newton law of recombination. Okay, let me tell that also here. Newton's law of recombination is nothing but when white light travels from one prism, you can see here, right? When white light travels, okay, this is white light travels from a prism, it gets dispersed into 7 colors, right? It gets dispersed into 7 colors. I'm not drawing here, just to understand this. Yeah, see here, it gets, right, when it passes through this prism, second prism, which is inverted but of same size, they get combined very quickly. See this one. They get combined and form again white light. This is the Newton's recombination. Is that clear? You will be having here prism 1, which is erect, and prism 2, inverted. Here there is band of colors. Okay, band of colors. They combine to form again the white light. I hope that's clear. Moving to next, that is atmospheric refraction. What is atmospheric refraction? Yeah, what is atmospheric refraction of light by earth? So refraction of light by earth's surface, right? Earth's atmosphere is known as, fine, understood, great. Yeah, I'm not explaining very detailed, Simran, right? I'm explaining the important only, not complete one. Okay, so yeah, the refraction of light by earth's atmosphere is known as atmospheric refraction. And what are the applications that you see over here? That is, due to atmospheric refraction, we see twinkling of stars, and sunrise and sunset, right? These are the concept. Twinkling of star is due to atmospheric refraction. Early sunrise and delayed sunset, it is also due to atmospheric refraction. Moving forward, scattering of light. What is scattering of light? Refraction of light in 2 medium, in which one medium is the Earth's atmospheric refraction. Refraction of light in 2 medium, in which one medium is Earth's atmosphere. Yes, that is also true. Yes, Tarun, that's right. Okay. Scattering of light. When a light beam hits the particles existing in the medium, some light rays get absorbed. We are not matter of that. Few get scattered. So, this scattering of light is nothing but the concept of scattering of light. Is that clear? When white light or when any light hits on a particle, it gets scattered in all the direction. That is called scattering of light. And what are the examples for scattering of light? Our sky appears blue, right? Sky appearing blue and sun appearing red are the application for scattering of light. Because blue light gets more scattered on the Earth's atmosphere, so we can see the sky blue. The light ray that is coming from the sun, it will not get scattered red color, so we can see the red in the sun, right? We can see the sun red color, but this will get scattered, so sky is blue color. What about if an astronaut see the sky from the space? It will be black. Why, ma'am? Because there is no particles in the medium, in space, so there is no scattering effect, so hence the sky in the space is dark. Next concept is Tyndall effect. Yeah, blue has less wavelength. Yes, exactly, blue has less wavelength, so it scatters. It is blue, and let's consider this to be a particle. Blue light will scatter after hitting the particle, but red has big wavelength, it will just pass through the particle, it will not strike on it. Yes, no atmosphere. Yes, Tyndall effect. The Tyndall effect is the phenomenon in which the particles are called as collide particles scatter the light beam in all the direction at them, is called as Tyndall effect. And very important, actually I have prepared this PPT and all, but I couldn't teach you the numericals from human eye, right? So quickly I'm gonna tell you how to solve the numericals from human eye, because they are also extremely important. If the questions come from there, I don't want you to miss it out. Clear? Clear to everyone? Just a second. Yes, don't distract anyone. Violet has less or more wavelength. Violet has less wavelength. Okay, less wavelength. Red, more wavelength. Yes, concentrate here. The far point, he is a myopic person, and the far point of myopic person is given 150 centimeter in front of eye. Calculate the focal length and power of lens to be used. So whenever it is a myopic person, the U should be far distance, far point of normal human eye. Okay, it is normal human eye. Yeah, students, stop that and concentrate here. Yes, focal length is 150. Exactly, directly also you can do. If it is for more marks, you can just show them by solving. Right? We know the length formula. 1 is equals to 1 by F is equals to 1 by V minus 1 by U. Yes, U is minus infinity. Remember that. Clear? I'll just substitute them. You can just solve this. One by infinity is nothing but 0. 1 by infinity is 0. Hence the focal length is, what's the answer? What is the power of lens? Yes, what is the power of lens? Yes, focal length is 150 centimeter. It can be converted into minus 1.5 meters. Clear? Power is equals to 1 by focal length in meter. So 1 divided by 1.5. What's the number? What's the number? Power. How much it will be? 0.66 diopter. 0.6. Yes, exactly. Is this problem clear to everyone? You were asking me numericals from human eye, so I have included it today. Okay? Clear? Just remember this. Myopia. For myopic person, far point, there is defect in the far point. Minus 0.66 diopter. Is it understood? One more time you want to tell me? That was fast. Okay, listen. This person is suffering from the defect of myopia. Hypermetropia is also there, okay? Hypermetropia is also there. Yes, I'll explain Simran. Can concentrate here. Myopia, the person can see the near objects but not far objects, right? So defect is in far point. So the normal human far point is the object distance. Normal humanized far point is the object distance. And what is the image distance? Far point of myopic eye. Clear? If you are, and both should be negative, okay? Both should be negative. Just remember this. You already know this formula, right? You already know this lens formula. Put the values. You also know the power formula. That's all. Nothing a big deal. I don't know how about this numerical. I studied yesterday from, yeah. Why and all, it's not the time to keep on explaining. But just remember, because you have exam. Y negative, virtual image. The lens produces virtual. You are always getting the image, right? So always U and V both are negative. I have another question also from hypermetropia. So let's be quick. A person with a defective eye, unable to see near object, nothing but he is suffering from hypermetropia. Is image distance where you cannot see is the object distance. Yes, that's exactly right. Okay, yeah. Yes, unable to see near objects, nothing but this person is suffering from hypermetropia. Okay, how to solve hypermetropia numericals. The near point of the person is 1.5 meter. He wants to read the book at 30 centimeter. Find the nature focal length of the lens. See here, that's the important thing over here. Yeah? All are negative. That's all. U and V, numericals, negative. Okay, at last moment you can do just that. Okay, it's not time to explain why, how and all, right? Okay, coming to here. So what is the normal? Normal human's near point. What is the normal human's near point? 25 centimeter. If in the question it is not mentioned, here it is mentioned 30 centimeter. If in the question it is not mentioned the near point of normal human eye, you should use 25 centimeter. Right? But here they have given 30. Here they have given 30. So I am using normal human eyes near point as minus 30 centimeter. And what is the defect? Defect can only see 1.5 meters. Convert this into centimeter. Yes, 1.5 centi. 0. Centimeter. Sorry, 150. Centimeter you have to convert it. Minus 150 centimeter. Now it's clear. Okay. Yeah. Again, go to the same lens formula. Okay. No new thing over here. Lens formula. 1 by F is equals to 1 by V minus 1 by U. 1 by V. 1 by minus 150 minus, here minus 30. Clear to everyone? These numericals are also important and they are previous year questions. Yes, minus 150 centimeter. 1 by focal length is equals to, if I take the LCM, 15 threes I could take, right? So yes, what will be the answer? Just a second. Yeah. Just calculation is left out here, right? So it is minus 3 plus 15. Great. Calculate this. Okay. If I take F over here, it will be 450 divided by 12. So what is the focal length? What is the focal length? It will be positive, right? Yes, focal length is 37.5 centimeter. If I want to convert this into meter, centi is nothing but 10 power minus 2. It will be 0.375 meters. Power is equals to 1 by focal length in meter. 1 by 0.375. And what is the power? It will be 2.66, I think. Yes? 2.66 diopter. Clear? 2.66 diopter. Is that clear to everyone? Again, just a power formula, lens formula. And you should be good with taking this values. That's all. Yeah? Yeah, you can sit on your bus and you can watch it, right? Yeah, 2.66 diopter. Exactly. And it is positive here, showing that it's a convex lens. Right? Hypermetropia can be corrected with convex lens, and here it is concave lens. Remember, you can write this 1 point extra also. Okay? Thank you. Yes. Next, electricity chapter. Very important, easy definitions. What is electric current? Centimeter to millimeter. Why you want to convert to centimeter to millimeter? Centimeter to meter, if you want to convert, it is 10 power minus 2. Milli means 10 power minus 3. Just remember these two values. That is more than enough. Okay, just remember these two. That is more than enough. Centi. C is nothing but 10 power minus 2. Milli, 10 power minus 3. Just write it down. Yeah. Okay. Rate of flow of electric charges is called as electric current. Very easy definition. I is equals to Q by T and Q is equals to NE. Clear? Electric potential is nothing but work done. Electric potential is the work done to bring unit positive charge from one point to another, is called as rate of flow of charge. Yes. Yeah. If you want to convert centimeter to meter, 10 power minus 2. Meter to centimeter, C, 10 power plus 2. Clear? Centi. Yeah. Yes. So potential difference, this formula is also important. 1 mark, 2 mark question they may ask from this simple formula, so it's important. What is power? Power is nothing but the rate of work done. Power is nothing but W by T, or power is equals to E by T, or power is equals to VI. I have provided all the formulas which are important in the sheet in the Telegram channel. Just go and check out it. 1 joule of work to do to move 1 coulomb of charge is nothing but 1 volt. Hi. Yes, to meter 10 power plus 2. Clear? Ohm's law very easy. Potential difference across the ends of the conductor is directly proportional to the flow of current in the conductor, keeping the physical conditions and temperature constant. This is only the statement of Joule's law. When you remove this proportionality symbol, you will introduce R, which is proportionality constant. And how is the graph? The question may arise from the graph also. So remember that it will be straight line, current versus voltage graph. Okay, good morning. Yeah, by using Ohm's law, V is equals to IR, you can derive many other formulas for the power. Clear? Yes. Resistance is nothing but the opposition offered to the flow of electrons. Resistance is directly proportional to length. Resistance is inversely proportional to area. Hence, we get the formula of resistance rho L by A. Clear to everyone? Resistance formula. And resistance is directly proportional to temperature. If we increase temperature, resistance also increases. Yeah. No, VI graph will be also straight line. IV graph also straight line, but resistance is difference. So if I take slope over this, graph, so what will be the value? Slope is nothing but R. Yeah, let me write it slope only. Slope is equals to opposite. Opposite is I by V. Okay. But from Ohm's law, we know that I by V is 1 by R. Clear? So this is 1 by R, slope. If it is V versus I graph gives the resistance. I versus V graph gives the reciprocal of resistance. Clear to everyone? Yeah. Clear? So remember that. I have explained this with a trick also. V, y-axis. If V is in y-axis and I is in x-axis, opposite by adjacent, then you will get the slope is equals to R over here. Clear? I hope that's clear to everyone. Good. And also remember this, temperature is directly proportional to resistance. Heating effects of electric current. Joule's law states that heat generated in the conductor is directly proportional to the square of current flowing, resistance and the time of flow. This is the Joule's law, right? In the question, if V is constant, you will use I square RT. If I is constant, this one, if V is constant, you will be using H is equals to, instead of I, V by R, we will substitute R square, R get cancels. So V square by RT. Remember this formula also, it is important. Yeah, what comment? Fast you want me to move? Okay. So these are the two important formulas from Joule's law of heating. Clear? Yeah. Now, applications of electric current, nothing but just remember 3 wires, right? The red color is given by live wire which carries the current, right? And green is by earthing. Green is by earthing and neutral wire. Clear? Yes, coming to here, fuse. Fuse has the tungsten. Tungsten is used to make the filament, so it is illuminated. In the bulb, in the fuse, in the fuse, yes, fuse will be made up of alloy, so by heating some point we can melt it down. Okay, is this clear? Earthing, fuse, I hope that's all clear. Entering to the magnetic field now. Quickly. Yes, we are with the last chapter. So, just a second. Yes, just it's been half an hour, I hope. Yeah, that's not a problem. Yes. Quickly. Magnetic field and magnetic field lines. What are magnetic field and magnetic field lines? Magnetic field lines are nothing but the imaginary lines which gives us the strength and direction of magnetic field lines, right? Which gives the strength and direction of magnetic field line. And what are the properties? Properties are important. You may get assertion reason question or MCQ kind of questions. Yeah. Good morning. Yeah. See here, closed curve, because it is completely making one circle, right? So closed curve. Do not intersect each other because at one point two directions cannot be given. Remember the reason also. Okay. Magnetic field lines are crowded near the pole, and the strength is more. Whereas there is crowd of magnetic field line, there the magnetic field is strong. Okay. The flow of from south pole to north pole. See here, inside it will be flowing from south to north, and outside it will be flowing from north to south. If you want a trick to remember here, I remember this as listen, I remember this as the Shiv, Trishul and Narayan's Chakra. Yes, Sudarshan Chakra. With that example, I remember this field lines, how it flows from each other. Okay, you can use that if you want. Moving forward, right hand thumb rule. When do we use right hand thumb rule? When current is flowing in a straight conductor, the magnetic field direction is given by the right hand thumb rule. The thumb finger indicates the current and rest of the fingers will give you the direction of magnetic field. Coming towards this current carrying in circular coil. In circular coil, you can see at two directions the current are flowing, and in the middle it will be constant, and you can find the direction using clock phase rule. Clear? Clear? Tell me, we are done now with some concepts. So this is North Pole. North Pole is generated in anti-clockwise if current is flowing in anti-clockwise direction. If it is in clockwise direction, South Pole. Good. Solenoid. Solenoid, solenoid, solenoid. Many were asking me, right? So yeah, we are with your solenoid. What is solenoid? A coil of many circular turns insulated on a copper wire wrapped closely in the shape of cylinder is called as solenoid. Is that clear? Is that clear? This, yes, good, good, good. This solenoid behaves like a bar magnet. What it means? One end will be North Pole, one end will be South Pole. If they ask you which is the North Pole of solenoid, which is the South Pole of solenoid, you have to see the direction of flow. If current is flowing in this direction, okay, current is flowing in this direction, then it is clockwise, right? It should flow in this to get north. Okay, if current is flowing in this direction, it is anti-clockwise. So North Pole is generated over here. From here, if you see, the current will be flowing in clockwise direction. So South Pole. Is that clear how to get the direction of solenoid? Yeah, guys. You want me to take your name? I'm struggling here to tell you for your exams, right? So I am very excited for your exams. One end of the solenoid behaves as the North Pole and other as the South Pole. Clear? The magnetic field lines inside the solenoid are parallel, nothing but constant. Or you can write uniform. Clear? Magnetic field lines inside the solenoid is uniform. Yeah, this one. Uniform inside. Clear to everyone? Yes. How to see the direction? Direction can be taken by left hand, Fleming's left hand rule. Thumb finger gives the direction. Forefinger gives the magnetic field and middle finger gives the direction of current. By using this left hand, Fleming's left hand rule, you can find the direction of force. You can find the direction of magnetic field and current. Clear? Fleming's left hand rule. I hope that's clear. Yes, domestic electric circuits. Oh, I explained there only. Yes, 3 wires. Green wire is a earthing wire. Live wire carries the current. And neutral wire completes the circuit. Okay, overloading concept important. When live wire and neutral wire come together, overloading occurs, or else if there is leakage and if there is use of multiple sockets in the circuit, you can see the overloading process, and the fuse is used to protect our devices from overloading. If high amount of current enters, also we can see that. So yeah, any doubts, any questions from physics? We are done. How to use Fleming's left hand rule? So yeah, just a second. So right side of your hand you can consider to be east, left, west, forward direction, north, backward, south. Right? By if they give proton is moving towards east. Proton is moving towards east. Nothing but current is formed towards east. So you can keep it like this. If they give magnetic field is outward in the north direction, you can keep it like this. Force, you can use this. Yeah, it's now last session of your life. No, it will be not like that. Okay, don't think that. We'll be, after exams, we'll study about fun physics. That will be more interesting. Okay, after exam. Yeah, grade 10. Of grade 10. Yes, exactly. Is it clear to everyone? Physics is done. Tell me, clear to everyone? Any question, any doubts from physics? Yeah, we have took the time. Yes. Thank you, ma'am. Welcome for that. I hope your physics revision is done and wishing you a very best for your exams. Do well, guys. Rock the paper, okay? Don't get scared. Don't get tensed, okay? Just rock the paper, do well, and come with the good news that, ma'am, we are done it. Okay, have that confidence, have that faith, everything will go good. Okay, don't worry about much things, everything will be absolutely fine. Okay, yeah. Yes, bye. Have that motivation, have that strength in yourself, and write the paper well. Ma'am, can you do bit grade 9th physics which are required? Yeah. Ninth also will be starting after this, so don't worry about that. Okay. Great, guys. Bye. Do well. All the best. Yeah. Okay. So let's hand over to bio ma'am.
Good morning, students. Just give me a minute. I'll just download the PPT. Huh? Yeah, you can stay. No. I mean, start ಮಾಡ್ತೀರಲ್ಲ ಮಾಡಿ.
Guys, all the best. So we are leaving. Okay. So concentrate in the class, and also ma'am is going to teach biology, revise biology for you. Okay, all the best. So we are going to pray for all of you. We really hope that exam is going to be easy and you remember everything that you have studied. Okay. All right.
Yes. All the
Bye
best.
guys. All the best.
And bye.
Just a minute, student. I'll download the PPT. Why? No, don't get scared. Just give your best, okay? You have prepared well. Just have that faith. Where is this? Yeah. Okay. So I'll revise all the 5 chapters. Okay. Okay. So our first chapter in biology is life process, right? Students, do you have any doubts in this? Do you have any doubts in life process chapter? Already I have told now what are all the important topics in life process chapter. Okay, I'll just revise the topics as fast as possible. Okay, fine. So yeah, life process, by now you already know, right, that within our body there are so many biochemical reactions that are taking place, because of which we are actually alive. Right. Now, for example, in our syllabus, we had life process chapter, we had nutrition topic, respiration, transportation and excretion, right? In nutrition, what is important? See, you might get for 2 or 3 marks the difference between autotrophic or heterotrophic, right? And then, in autotrophic mode of nutrition, we studied photosynthesis, right? We studied photosynthesis. Right, in case if they ask photosynthesis for 5 marks, okay, you will have to define what is photosynthesis. What is photosynthesis, students? It is a process by which the plant prepare their own food. How? By utilizing the carbon dioxide, water molecule, sunlight, and in the presence of chlorophyll, the carbohydrate is generated. Right. That is your definition. What are all the raw materials for photosynthesis? What are all the raw material for photosynthesis? I told you carbon dioxide, water, chlorophyll pigment and sunlight, right? And then the site of photosynthesis is leaf. What are all the three main steps that are involved in photosynthesis? First one is absorption of light by the chlorophyll pigment, and then second one is the conversion of that solar energy into chemical energy and splitting up of water molecule. When the water molecule is split, the hydrogen is released, oxygen is also released into the environment, and that hydrogen will reduce the carbon dioxide into carbohydrate, right? So you will have to mention those three steps, and then after that you will have to then mention the significance of photosynthesis. What is the significance? That is, the plants are the main living organ. They are the only life form which are capable of capturing that solar energy and making it available to the other life form, and then they are the main producer of food. Plus the photosynthesis, it also helps in balancing carbon dioxide and oxygen, right? Okay, so Madhumitra, you want me to explain root pressure and transpiration pull? Yes. So root pressure and transpiration pull, they play a very important role in the transportation of water in plants. Okay. So now I told you, no, see, plants, how do they transport water? See, from where are they getting water? They are getting the water from the soil, right? The root, it will absorb water from the soil. So how is water entering into root from the soil? It is through diffusion and osmosis process. Okay, fine. See here, the cells that are present in the root, they are in direct contact with the soil. So over there, diffusion, osmosis works. Then from root to the tip of the plant, the water has to be transported. And in case the plant is short, if it is still small, its height is small, then the diffusion works over there. But then what happens in case of tall trees, tall plants, over there the diffusion doesn't work, because in case of diffusion and osmosis, the water will have to pass from one cell to each, it will have to pass each and every cell. And in case the plant is very tall, then it is highly impossible to reach the tip in shorter period of time. It takes years to reach the tip in case if the water is transported via diffusion or osmosis. That's why proper transportation is needed in plants, right? So here the xylem, there are certain conducting vessel. For example, the xylem, it transports water in plant, and phloem, it transports food in plant. Right? So now, what is transpiration? Transpiration is nothing but evaporation of water. You know that, right? That is the evaporation of water, right? So from where is water getting evaporated? From the leaf. So the water molecule that is present in the leaf, see, there is stomata that is present on the epidermis of the leaf, right? When the stomata opens, what happens? The excess water is evaporated. The water gets evaporated from the leaf, right? So then what happens in leaf? That empty space is created, because of which there is suction force that is created. And then that suction force which is created in the leaf, that force will pull the water molecule which is present in the root. So that transpiration, because the transpiration has occurred, the suction force is created. Because of that suction force, the water is pulled up. It's because transpiration is playing important role in pulling that water up. It is called as transpiration pull. Okay, Madhumitra, understood with the transpiration pull? And now what is root pressure? What, ma'am? They are... It's okay, just ignore and listen to the important concepts, okay? And students, if there is any doubts, comment in the comment section, fine? Okay. So now, that is about transpiration pull. Clear with that, Madhumitra? Okay, and the next one is root pressure, right? See, during night times, the transpiration does not occur much. It is very less. Okay, so night times, transpiration pull does not work much. So night times, root pressure comes into picture. So what is happening is that, I told you that the root absorbs water, right? It absorbs water continuously. What happens is that the cells that are present in the root, they absorb water continuously from the soil. And it's because the water is absorbed continuously, there is a push that is created. Where in the root, and that pressure is pushing the root upward during that is pushing the water molecule upward during night time. That is called as root pressure. Clear with that? Clear with that, students? Clear with that, Madhumitra? Did you understand? Did you understand? Okay. Tarun, you want me to explain the KOH that is kept near the plant, that experiment? Okay, okay, Tarun. See, that experiment is conducted to show the importance of carbon dioxide as a raw material. Okay, Tarun. So, what are they doing is that they are taking two healthy plant. Okay, the two, first they choose two healthy plant, and the two healthy plants are kept in dark for some 2 days, 48 hours to 3 days. Okay, why? So that the stored starch should be used by the plant. For that, the plant is kept in dark for some days so that there is no photosynthesis that happens. Okay, and then what happens is that the next thing is, then the plant is taken. The two healthy plant, it is covered by a jar. It will be covered by a jar, and in case 1, you have seen the diagram, no, Tarun. In case 1, along with the plant, in a watch glass, the potassium hydroxide is also placed. Whereas in the second case, the plant is just covered by a jar, and both these plants are kept where there is availability of sunlight. Okay. So what is happening is that in case 1, in that watch glass, there is KOH, right? The KOH, it is capable of absorbing the carbon dioxide. The KOH, it absorbs carbon dioxide. As a result, the plant will not get carbon dioxide. Okay, so during daytime, what happens is that when the plant is kept in sunlight after 3 days, what happens is that the plant will perform photosynthesis. It will utilize the available carbon dioxide that is present, and it will, perform photosynthesis, and oxygen is released. But after some times, what happens? The KOH that is present will absorb the carbon dioxide, and it forms carbonate. Okay, I'll write that reaction. What happens is that, see, the KOH, when it reacts with carbon dioxide, it forms K2CO3. This is the, see, the carbonate is formed. So this is not available for the plant. As a result, what happens? The plant cannot perform photosynthesis in the first case. Whereas in the second case, there is no KOH. It's because there is no KOH, the plant, it performs photosynthesis. Oxygen is released, and then after photosynthesis, the plant would have generated some amount of sugar, right? Then now they have to derive energy from that sugar, from that glucose. So what will they do? They will absorb the oxygen that is present within the jar to perform the respiration process. After respiration, again carbon dioxide is released. Again that carbon dioxide is available for the plant to perform photosynthesis in case of second case, where the KOH is not present. Whereas in the first case, it's because KOH is present, it will absorb all the carbon dioxide, because of which after some time the plant cannot perform photosynthesis and the plant will die. Okay, students, did you understand, Tarun? KOH is nothing but it is an experiment that is conducted to show the importance of carbon dioxide as a raw material. Clear with that? Yes, Kelvin, I'll be explaining feedback mechanism as we go further. Okay, we'll finish in this chapter. If you have any doubts, yes, Madhumitra, I'll explain feedback mechanism in hormone. And then you want me to explain the respiration in aquatic organism. See, the respiration in aquatic organism is nothing but, see, Madhumitra, that is not that important. Learn about, see, the respiratory system in respiration in human being is important. And then what is important in aquatic organism is that you will have to mention which type of respiration organ is present in aquatic organism. Which type? It is gills. Aquatic organism, they use gills as the respiratory organ, whereas unicellular organism, they use their cell membrane itself as a respiratory organism, whereas frog and earthworms and all that, they use their skin as respiratory organ. And then what about insects? They have spinacles that is used as respiratory organ. Okay, Madhumitra? Okay, fine. Thank you, Madhumitra. Thank you. So, yeah, clear with that, students? So, I explained photosynthesis also. After photosynthesis, under nutrition topic, the human digestive system is, like, from there you get 2 mark, mostly you get 2 mark, 3 mark, or else they will give you the human digestive system diagram, and they will ask you to label certain part and mention its function. So, in human digestive system, what is there? We have already studied alimentary canal and associated gland, right? So, here associated gland, that is important. Which gland is secreting which hormone? Salivary gland, which is present in buccal cavity, is secreting salivary amylase that converts starch into maltose. And then comes stomach. In stomach, gastric gland is present. Pollination. Yes, Santosh, I'll explain pollination after this. Okay, shall we finish it off in another 10 minutes, the entire life process chapter? I'll summarize the entire life process chapter, important topics in 10 minutes. Just give me 10 minutes, okay? I'll cover this off and I'll move on to, there was one topic, right? Madhumitra also had asked. Let me check, the pollination I'll explain, and then feedback mechanism. I'll just finish this in 10 minutes, okay? Bye, Quizmaster. Bye, all the best. Okay. And then in gastric gland, which is present in the stomach, that secretes HCl, mucus, pepsin. You know the function of HCl? It kills microorganism that is present in the food, and also it is activating the pepsin enzyme, which is a protein digestive enzyme. And then comes liver secretes bile juice. What is the function of bile juice? One is it converts that acidic food into alkaline, and the other function is it is involved in emulsification of fat. And then pancreas, it has three enzymes, trypsin, lipase, amylase. Trypsin, it breaks protein, and lipase, it breaks fat, and then amylase, it will completely digest the carbohydrate. Okay, and then there is, in intestine, the complete absorption occurs. You know, right, why complete, after complete digestion, absorption also occurs in the small intestine itself. Why? Because of the presence of villi. Within villi, what is present? Blood capillaries are there. Within blood capillaries, there are blood that is flowing. So now what happens is that from small intestine, that those digested nutrients, they will get absorbed into the blood capillary. It will diffuse into the blood capillary, and then the blood will carry those important nutrients to each and every cell that is present in our body. That is all about nutrition part, okay? From that only they expected, ask question. Okay, students, that is about nutrition, where you will have to focus on photosynthesis. And the other one is human digestive system, from where they will mostly ask about enzymes and the function of that particular part. Okay, and then after that, we studied about respiration, right? We studied about respiration. What is happening in respiration? See, now the food is completely digested, where in small intestine. And now the blood carry that nutrients to the cells that is present in our body. So now, after that nutrients enters into those cells, what is happening to those nutrients? Now, first of all, why are we eating food? Because we want to derive energy, right? So, we eat food and we are deriving energy from that food. How? First, digestion is happening. After digestion, these digested nutrients are broken down to release energy in the form of ATP. That process is called as respiration. And again, respiration is of two types, aerobic respiration and anaerobic respiration. Okay, it is aerobic respiration and anaerobic respiration. In case of aerobic respiration, what is happening? The glucose is broken down in the presence of oxygen, whereas in case of anaerobic respiration, the glucose is broken down in the absence of oxygen. Okay, the aerobic respiration occurs in higher organism, and 36, remember the students, 36 to 38 ATP molecule are released in case of this one. What? Aerobic respiration. In case of anaerobic respiration, it is only 2 ATP. Anaerobic respiration, you should remember two things, students. Alcoholic fermentation, nothing but the anaerobic respiration that is taking place in the yeast cell. What is happening in the yeast cell? The glucose is broken down. First, the glucose is broken down into pyruvate, and then the pyruvate is broken down to release ATP, which is 2 molecule. Along with that, carbon dioxide and ethanol is also released. In case of muscle cells, in muscle cells also anaerobic respiration takes place, which is also called as lactic acid fermentation. Why? Because when the glucose is broken down into pyruvate in the muscle cell, there is no oxygen, right? So the pyruvate will be broken down to release ATP. Along with that, lactic acid and carbon dioxide is also released. So that lactic acid, when it gets accumulated in the muscle, it causes muscle cramp. Okay, that is all about the types of respiration which you will have to remember. Okay, after that, you should focus on the respiratory organ, human respiratory organ, and in plants also respiration occurs. Respiration occurs during daytime as well as night time. Okay, and what are the respiratory organs that are present in plants? It is stomata in leaf, lenticels. Students, remember this, it is lenticels in the stem, and then the root hairs in the root. Okay, clear with that? And in case of human beings, animals, which is the respiratory organ that is playing important role? We have lungs, right? We have nasal cavity, we have pharynx, larynx, trachea, bronchi, that is divided into bronchioles, alveoli, we have paired lungs. So these are all the parts of human respiratory system. Okay, that is all about respiration, students. They will give you a diagram, you will have to label the parts. And breathing mechanism is important. and breathing mechanism important, from which the question can be asked. You will have to write for that. So when you inhale, what is happening? While inhaling, what is happening? See, the diaphragm moves downward. Remember the students, when you're inhaling, diaphragm moves downward, the chest cavity expands, because of which the air pressure that is present in the lungs decreases. So we inhale. When you are exhaling, what is happening in the lungs? The diaphragm moves upward and the chest cavity, it contracts and air pressure increases. That's why we exhale out. Okay, that is all about respiration that you will have to remember. And they will ask you the difference, they might ask you the difference between respiration and breathing. See, respiration is a biochemical process, breathing is a physical process. Okay, when you breathe, our lungs, it will absorb oxygen, and that oxygen is made available for the respiration process to take place. Okay, clear with that, students? That is about respiration. After that, transportation. So now I told you, now the food is completely digested in small intestine, and then the lung absorbs oxygen, right? So now who is it that is carrying nutrients from the small intestine and oxygen from the lungs to the each and every cell that is present in our body? We require some vehicle, no, to transport, right? So what you will have to do, blood is behaving like a vehicle which carries the nutrients from small intestine and oxygen from the lungs and carries it to the cells that is present in our body. Ma'am, trachea ka diagram bata do. Trachea, see, that is your lungs, students, nothing but, see, let's say this is your nasal cavity, right? And then rough diagram, there is pharynx, larynx, and this is your trachea. Trachea on which the you will get to see cartilaginous rings. You will get to see cartilaginous rings. Ma'am, please explain respiration in aquatic animal. Madhumitra, are you sure respiration in aquatic animal is not at all there in your syllabus? What you will have to know is, you will have to remember the organs that is, the respiratory organ that is present in the aquatic animal. Ma'am, please explain systemic and pulmonary circulation. Yes, I'll explain that now. There was a student who asked me to draw trachea. See, this is your trachea which has got cartilaginous ring, and then the trachea is divided into bronchioles, and then the bronchiole, see, this is the lungs, right? Lungs, and then bronchiole is divided into, further it is divided into bronchioles. You can see this, no? These are bronchiole. At the tip of bronchiole, alveoli is present, and this is trachea. That is trachea. Okay? Okay, clear with that? Okay, fine. So now moving on to, yes, Madhumitra, now we are doing transportation only. What was I telling? The blood behaves like a vehicle, and then it flows through blood vessel. What are all the blood vessels that are present? Arteries, veins, and capillary. Artery carries oxygenated blood from heart to different body parts, whereas veins carry deoxygenated blood from different body parts to heart, and blood capillary is behaving like a bridge between arteries and veins. Okay, clear with that? So yes, I'll explain the nephron structure. Next one is control and coordination. I'll explain that. After transportation, I'll explain excretion. That time I'll explain the nephron part. Okay. Okay. So yeah. What are all the components of the human circulatory system? Blood, blood vessel, and heart. So heart is important. You should remember the why is it divided into 4 chambers. You know the reason, right? And then you should remember what are the valves that are present and how the blood is flown through the heart. Okay, and then Madhumitra, you are asking about double circulation, right? So why the circulatory system in human beings, why in mammals it is called as double circulation? Answer is very simple, because the blood, it travels to heart twice. Once oxygenated form, second time deoxygenated form. Okay, see, in double circulation, that's why it is called as double circulatory system. And in case of double circulatory system, 2 pathways are followed. One is systemic and the other one is pulmonary circulation. Systemic circulation is between the heart and different body parts. Okay, and the pulmonary circulation is between the heart and the lungs. Okay, so now what happens is that I told you the heart, it pumps oxygenated blood to different parts of the body, and from different parts of the body the deoxygenated blood is carried back to the heart by veins. So this circulation is systemic circulation, Madhumitra. Okay, whereas pulmonary circulation is between the heart and the lungs. See, when the deoxygenated blood reaches the heart, The heart pumps the deoxygenated blood to the lungs. In lungs, the deoxygenated blood is converted to oxygenated, and then that oxygenated is brought back to the heart by pulmonary veins. That is the pulmonary circulation. Okay, clear with that? I just explained the Madhumitra, systemic and pulmonary circulation. Systemic circulation is the circulation that is occurring between the heart and the different body parts, whereas pulmonary circulation is the circulation that is occurring between the heart and the lungs. Okay, clear with that? So that is all about the circulatory system in human being. And in case of the circulation in plants, I already explained the transpiration pull and root pressure, right? That is about the transportation of water. Who transports water? It is, ma'am, why veins have valves, right? That should be your question. Valves because to prevent the backward flow. Okay, Raghu, you want me to differentiate between arteries and veins. Okay, arteries, they have thick wall. The walls are thick, whereas veins, they have thin wall. Arteries carry oxygenated blood from heart to different body parts, whereas veins carry deoxygenated blood from different body parts to the heart. Okay, why the arteries have thick walls? To tolerate the high pressure when the oxygenated blood is pumped from the heart. Okay, and then the veins, they have valve. Why? To prevent the backward flow of the blood. Okay, Raghu, did I clear your doubt? Fine. So that is all about, and then when it comes to transportation system in plants, the two things that you will have to remember is xylem and phloem. Xylem transports water, how? Through transpiration pull and root pressure, whereas phloem, it translocates food from leaf to different parts of the body, and then the movement of food in phloem is bidirectional, and then it is active movement. Why? Because ATP is utilized. Okay, that is all about transportation system. And then moving on to excretion. See, when I say human excretory system, it is all about the removal of nitrogenous waste. It is the removal of nitrogenous waste from our body. There was a student who asked about the structure of nephron, right? Now I'll explain the structure of nephron, students. Listen to this carefully because that is important. Okay, so now human excretory system has got a pair of kidney, ureter is two ureter is there, urinary bladder and urethra, right? So I told you that kidney, it filters nitrogenous waste from the blood. How is kidney filtering nitrogenous waste? Because it has got nephron. What are nephron? Nephrons are the, first you should write, nephrons are the filtering units that is present in kidney. Okay, so the nephron, it has got a capsule like structure which is Bowman capsule, and that Bowman capsule it surrounds a blood capillary, a mass of blood capillary which is called as glomerulus. Okay, and then the Bowman capsule, it leads to the tubular structure of the nephron, and finally the tubular structure, it reaches the collecting duct. Okay, so first what happens is that the blood, when the renal artery carries the blood carrying nitrogenous waste to the glomerulus. When the blood flows through glomerulus, all the nitrogenous waste, along with nitrogenous waste, the important substances that are present in the blood like glucose, amino acids, salts, they are also filtered out from the blood and will be collected in the Bowman's capsule. It forms a fluid which will have nitrogenous waste and other important substance. But then our body requires those important substance. If we lose those important substance, then it will cause harm to our body. So then what happens is that the Bowman capsule, it allows this fluid to pass through the tubular structure of the nephron. When it is passing through the tubular structure of the nephron, what happens is that again around tubular structure, the blood capillaries are present. So these blood capillary, what it does is, within blood capillary there is blood that is present. That blood will reabsorb the important substances back from that fluid which is passing through the tubular structure. What are those important substances? Glucose, amino acids, salts and all will be absorbed back. So reabsorption is taking place when the fluid is passing through the tubular structure. Now the tubular structure has got three parts: proximal convoluted tubule, loop of Henle, distal convoluted tubule. After the fluid reaches after it reaches the distal convoluted tubule, when it reaches there, all the important substance will be reabsorbed back and only nitrogenous waste will be left. So urine is formed, and then that urine gets collected in the collecting duct, and from the collecting duct it comes out of the kidney and then it will be collected in the urinary bladder. And till the pressure creates in the urinary bladder, that urine will be stored there only. Once the pressure is created, the urine is released out. Okay, gaming with Ashwin. Okay, so clear with that, students? Did I explain your what nephron diagram in short? You got an idea, right? You will have to write these points. Reabsorption, you should mention this, you should draw neat diagram, label the structure and mention what is happening in which part of the nephron. Okay, clear with that? This is all about. And then excretion in plant is, they might ask for 3 marks only, not for 5 marks. If they ask for 3 marks, just you will have to mention that, see, the gaseous wastes are released from plant through stomata, and excess water gets evaporated through transpiration process. That also happens through stomata only. And then root also releases some excess salt which is not needed for the plant, into the soil, right? And also the older leaves which will fall off from the plant, that also carries waste material which is not needed for the plant, right? After that, what happens? Sometimes the waste material also will be stored in the vacuoles, right? You should mention all that. Ma'am, when kidney could not work properly, that one process occur, what process? Okay, in case of kidney failure patients whose kidney is not working, that time the patient will have to undergo hemodialysis, which is also called as artificial kidney. So what is done is that from the patient's body the blood is taken out. That leads to which part? They remove the blood, like it is connected to the dialysis. The blood flows through the dialysis. When the blood flows through dialysis, the nitrogenous waste is filtered out and the purified blood is sent back to the patient's body. But in case of artificial kidney, the double reabsorption does not occur. Okay, smart boy, just before 5 minutes I have explained the nephron. Just rewind back. Okay, student, clear with that? Understood, right? Hemodialysis. When the patient's kidney is not working properly, then patient will have to undergo hemodialysis, where the blood is taken out, it is filtered, and then the nitrogenous waste is filtered from the blood, and the filtered blood will be, purified blood will be sent back. Okay, ma'am, when the gallbladder is removed, see, the thing is, the patient should avoid the reduce the consumption of fat. Why? Because I told you liver secretes bile juice, and then the bile juice will be stored in gallbladder for some time. Okay, but when the gallbladder is not there, it will not be stored. So that will somewhere affect the emulsification of the fat. Okay, clear with that, students? So this is all about life process chapter. Shall we move on to the next chapter? Yes. I will explain that, student. Just a minute. I'll just come back 1 minute. Yes. Now moving on to control and coordination chapter. Students, in case of control and coordination chapter, what is important? You know, nerve cell you might hardly get for 2 mark. Nerve cells you might hardly get for 2 mark. Okay, yes, Kalaif, I will explain that. Just give me 10 minutes, I'll finish off this as well. Okay, so now you will have to draw the nerve cell diagram and mention the parts and explain its function. You all know that, right? After that, then what is important? The transmission of electrical impulse. The transmission of electrical impulse is important, right? I have explained that also, the transmission of electrical impulse. You know that, right? That is important. After that, reflex action is very, very important. In this chapter, reflex action, the function of reflex arc. Okay, I'll explain the reflex action, which is important in this chapter. See, reflex action is that immediate involuntary response. Okay, whereas reflex arc is then a reflex arc. Okay, reflex arc is the pathway. Tarun, I didn't get you, ma'am. Your cells have cell. What is that? Okay, so reflex arc is the pathway. Reflex action is the response. That is the immediate response. Okay, so first what happens is that, again I'll give you the same example. I've repeated this n number of times in my previous session also. This is the best example, students, and easy to represent also. That's why you mentioned this. Now, without my knowledge, maybe I'm turning somewhere that side, I'll touch hot vessel, immediately I'll take my hand back, right, when I feel the heat. How am I doing that? Because there are receptors that are present in skin. So first, what will that receptors do? The receptor will identify that stimuli, and then that signal is passed. So from receptor, who passes the signal? Which neuron passes the signal? It is sensory neuron. The sensory neuron transmits the electrical impulse. Okay. In case of reflex action, brain is not involved. Instead, only spinal cord is involved. Okay. So what happens is that when the sensory neuron reaches the spinal cord, then what happens is that electrical impulse is not sent to brain in case of reflex action. Instead, the associated neuron will pass the response. It will pass the response to the motor neuron, and then the motor neuron will send that response to the target organ, and then target organ will respond to that situation. So in case of reflex action, brain is not involved. It is only controlled by spinal cord. And what are all the types of neuron that is involved? It is sensory neuron, associated neuron, and motor neuron. Okay. And then, ma'am, what is the part between two myelin sheaths? Yes, in the axon structure, there are myelin sheaths, right? In between myelin sheath, there is a gap. That gap is called as nodes of Ranvier. Okay. Now, what is the function of that myelin sheath and those gaps? See, it makes sure that the electrical impulse, when it is transmitted through the neuron, the speed should be high. It maintains that speed, it regulates the speed, and also it makes sure that the electrical impulse does not break in between. It should not break in between. Okay, dendrite cell, body axon, and yes, Lalit, that is, you will just have to, in case if even if they ask nerve cell diagram, it is for 2 or 3 marks only. It won't be asked for 5 marks. Okay, students, now it would be better if you have doubt, I will explain the pertaining to control and coordination. Okay. Find which mode of reproduction likely to have more percentage of survival sexually. Why? The mode of reproduction. Be specific, Lalit. Be specific. I didn't get you. What are you saying? Okay. So, yeah, students, and you all know, right? In that control and coordination, the first part we studied about the components of nerves, right? Where you studied about neurons, and we studied about receptors, how the electrical impulse is transmitted, and all that. I have explained that in depth, right? And then we studied about human nervous system. Human nervous system has got central nervous system and peripheral nervous system. Central nervous system is the brain and spinal cord. In case of brain, there is, brain is divided into 3 main parts: forebrain, midbrain, hindbrain, and again the forebrain has got cerebrum, thalamus, hypothalamus, right? What is the function of cerebrum, students? Ma'am, explain nastic movement. Yes, I'll explain as we go further. Okay, what is the function of cerebrum? That controls the intelligence, your willpower, and IQ and all that. That is controlled by cerebrum. What is thalamus doing? It is acting like a relay center, right, between hypothalamus and the cerebrum. What about hypothalamus? Hypothalamus, it regulates the thirst, your body temperature, as well as feeling of when you feel hungry, sometimes when you eat too much, you feel full. All that is controlled by hypothalamus. And also hypothalamus, it regulates pituitary gland as well for the secretion of enzyme. Okay. And then, yes, Lalit, yes, food chain, I'll explain you as we go further to our environment chapter. Okay. So, that is all about forebrain. And then there is midbrain. Midbrain is also, it is present between cerebrum and hindbrain, right? That is also main. What is the main function of midbrain, students? See, it controls those activity which does not require much of thinking. For example, blinking of eyes, and sometimes when you sit on a chair, or maybe without your knowledge, you will just turn the chair, you'll move the chair and all that, right? You'll turn around. So, all those things does not require much of thinking. So, those activity which does not require much of thinking is regulated by the midbrain. And then moving on to hindbrain. Hindbrain has got cerebellum. It has got cerebellum, pons and medulla oblongata. What is the function of cerebellum, students? It maintains the body posture. It helps us to balance and all that. What about pons? What is it doing? And what is medulla oblongata doing? Medulla oblongata, involuntary action, right? It controls the involuntary action. So the important thing in brain is you will have to, ma'am, time up, I want to, okay, you can carry on, students. All the best for your exam. I know you all will do great. Okay, I know you all will do great. You will rock the exam. Fine. Okay. So, yeah, where was I? Brain part, you will have to mention the part and explain its function. That is important. Yes. Okay, and then spinal cord. See, from spinal cord, what are the nerves that is arising out? You will have to mention that. Cranial nerve, spinal nerve. How many pairs of cranial nerves are there? Cranial nerve, 12 pairs. How many pairs of spinal nerves are there? 31 pairs. You will have to mention that. That is important. Human nervous system. And then moving on to endocrine system. Which are all the glands that are present? What hormone that is secreted and what is its function? That is important. Look at this. Endocrine glands. Okay, we'll start with this. See, the glands in humans. See, the thymus will secrete thymosin. Right. Before that, the pineal gland. The first one is the pineal gland, which secretes growth hormone, tropic hormone, prolactin, vasopressin, oxytocin and all that. And then comes your thyroid gland, which secretes thyroxine, that regulates. Ma'am, please explain that. Lalit's doubt, it seems like it is time up for him. Okay, Lalit, what is your doubt? Ma'am, food chain. Food chain, that is the 10% principle. You want that? Okay, I'll show that to you. I'll show that slide to you. I have the explanation also. See, students, what happens is that, see, in this trophic level, you know, right, the movement of energy is unidirectional. Mention that first. Movement of energy is unidirectional, right? It is always unidirectional. See, the green plant, it captures 1% of sunlight. That, actually it takes that entire 100, it is capable of capturing some percent of sunlight. Out of that, some percent, 99% is used for other purpose, whereas that 1% of sunlight is converted into food energy. And then that energy is passed on to the next trophic level. So now, what is the 10% law is nothing but, look at this, the 10% of energy is transferred to next trophic level. It is transferred to next trophic level, whereas remaining 90% of energy is used in life process like digestion, growth, reproduction and all that by present trophic level. Students, if you want, you can take screenshot of this and you can revise this when you are going on the way. You just draw this diagram and if you add these 4 points, more than enough for that question. More than enough. 1 second, student, I'll explain your adrenal gland. Lalit, if you want, you can take screenshot of this. When you're going on the way, you can just go through. Mention these points, that is very enough. And then what happens? The energy as it goes higher and higher, the energy decreases. The solar energy, the amount of energy that is supplied decreases. Right? So that's what is represented over here. First it is 1 kilojoule. And then it is 10 kilojoule, and then it is 100 kilojoules, and finally 1000 kilojoules. That's why in your trophic level, hardly there are 4 levels, not more than that. Why? Because even if there are more than that, it's waste only because energy does not reach. Okay, Lalit, clear with this? Okay. So, ma'am, what is adrenal gland? I'll explain that now. We'll go fast, right? You all have exam. We'll finish it off as fast as possible now. So, adrenal gland, where is it present? It is present above the kidney. Okay, it secretes adrenaline. Okay, what is the function of adrenaline? See, when you're stressed, when you're getting scared, that time adrenaline hormone will be released. In the emergency situation, adrenaline hormone will be released. Okay, why? So that, now for example, let's say you got scared, immediately you will run. For you to run, you require energy also, right? So, how is that energy released? So, first what happens? Adrenaline gland will secrete adrenaline hormone, which will increase your blood pressure. Along with that, it also, makes that glucose, the stored glucose available. Why? So that you get energy and you react to that emergency situation. So, adrenaline the adrenal gland secretes adrenaline, which is a fight, flight, fright hormone that is secreted during emergency situation. Okay, Lalit, Tarun, all the best for your exam. Okay, all the best. Evening we will discuss the paper, question paper. Okay, fine. So that is all about adrenal gland, and then comes pancreas. Pancreas are there, that is also important. Pancreas, it will secrete insulin and glucagon. Insulin will decrease the blood glucose level, whereas glucagon will increase the blood glucose level. Okay, ma'am, biomagnification. Okay, biomagnification is nothing but it is the accumulation of the toxic. See, as you go higher and higher, see, I told you, from one trophic level to another trophic level, the energy that is passed on is less. The energy will decrease, right? When it moves upward. When the energy moves upward from primary, secondary, tertiary trophic level, the energy decreases. Whereas the amount of chemical accumulation increases. That accumulation of the chemical substance which is toxic gets accumulated more in the higher trophic level. That is called as biomagnification. Okay, students, clear with that? Fine. And then glucagon, like I told you, it will increase the blood glucose level. And then parathyroid, parathyroid gland, it is not there in the syllabus, but remember this, it will regulate the calcium level. Okay. And then there is testes in male, which will secrete testosterone, and ovaries in female, it will secrete estrogen and progesterone. Okay, clear with that, students? And then moving on to plant. Okay, there was a student who had asked about nastic movement. You had asked about nastic movement, right? So what is nastic movement is nothing but, see, plants, no, they show two types of movement. One is nastic movement and the other one is trophic movement. For your exam, trust me students, trophic movement is very, very important. Okay, nastic movement, see here, for example, touch me not plant. You touch the leaf. What happens? Immediately the leaf will get closed. Right. So now the movement of the leaf is absorbed, right? Now is that movement, whether that movement is in the direction of the stimulus, is it in the direction of the touch? No, right? Here, in case of nastic movement, the movement that is shown by the plant is not in relation with the stimulus. It is according to the plant only. So here, in case of nastic movement, the movement and the response and the stimulus are not related. In case of nastic movement, best example is touch me not plant. Whereas in case of trophic movement, what is happening? The plant responds to the stimulus. If the plant grows towards the stimulus, then it is called as positive trophic movement. If it moves away from the stimulus, then it is called as negative trophic movement. And in trophic movement, there are phototropism, geotropism, hydrotropism and chemotropism. See, phototropism is nothing but here the movement of plant that is affected by the light. If it is towards the light, then it is positive. If it is away from the light, then it is negative. What is geotropism? Geotropism, it is the movement is in response to the gravity. If it is towards the gravity, then it is positive. If it is away from the gravity, then it is negative. And then hydrotropism is by water. It is in response, the movement is in response to the water. Okay, if it is towards the water, then positive. If it is away from the water, then it is negative. Chemotropism is because of the chemical. The movement is regulated because of the chemicals. For example, pollen grain, when it sits on stigma, the pollen grain, it will form pollen tube. That is example for chemotropism. And there is stigmotropism, where touch is behaving like a stimulus. Insulin hormone. Yes, insulin hormone, like I told you, it is secreted by pancreas and it will decrease the blood glucose level. It will reduce the blood glucose level. Okay, clear with that? Ma'am, please explain my doubt once. Will you please tell, ma'am, how to brain? What was, 1 minute, I'll just check your comment. How to brain? See, the brain is not involved in reflex action, students. Brain does not control reflex action. Remember this, the reflex action is controlled by spinal cord only. Whereas involuntary action, when I say involuntary action, that is controlled by medulla oblongata, which is present in the brain. Okay, students, clear with that? So this is all about control and coordination chapter. You will have to remember that human nervous system, spinal cord and different parts of the brain and its function. And then the movements in plant, hormones plant hormones. Plant hormones, there are 5 important hormones: auxin, gibberellin, cytokinin, abscisic acid, ethylene. Auxin, it helps in, you know, cell elongation. Okay, cytokinin plays very important role in cell division. And then gibberellin, it plays very important role in elongation of the intercellular, internodal part. Okay, and then abscisic acid, it is very important growth inhibitor, and it also causes dormancy in seeds. Okay, and then comes ethylene. Ethylene is a gaseous hormone which is seen in ripening fruits. Okay, clear with that, ma'am? Please explain what I guess I explained your doubt. Then is there any other doubt from the students? Just tell me. Is there any other doubt from this chapter? Or else we'll move on to the next one. We'll move on to the next one. Okay. Reflex arc in brain is indirectly connected with, see, first of all, reflex arc is the pathway, students. Reflex arc is the pathway that is followed. Reflex action is that involuntary response. Monohybrid and dihybrid cross. Okay, I'll explain monohybrid. You want me to write monohybrid and dihybrid cross? See? Yes, from this, now we'll do heredity chapter, students. From heredity chapter, monohybrid cross, dihybrid cross are important, and also sex determination. These are the three important topics. Okay, these are the three important topics. Krishu, you want me to draw monohybrid and dihybrid cross? Tell me fast. No, just tell what it is. Okay, in case of monohybrid cross, why it is called as monohybrid? Because over here only one character is considered, only one trait is considered. For example, Mendel, he used pea plant, and in case of monohybrid cross, he considered only the height. He crossed the tall pea plant. The tall pea plant was carrying homologous gene. Both were capital T, and he crossed the tall pea plant with the short dwarf pea plant, which was carrying small t, which is homozygous gene, right? When that is crossed in the F1 generation, you get all tall plant, but then they will have heterozygous gene, that is one capital T and small t. And then when you self cross that F1 generation of monohybrid cross, you will get 3 tall plant and 1 dwarf plant. That is monohybrid cross. Okay, what did monohybrid cross prove? It shows the law of segregation. Okay, it shows the law of segregation. Okay, students, what is law of segregation telling? The alleles of the two genes, okay, see here, they get sorted independently, that is your independent assortment, and here the two alleles which are present in the gene, it is getting separated during gamete formation. And how is it getting separated? And it is independently, it is getting separated. That is your law of independent assortment, which is proven by dihybrid cross. For dihybrid cross, what did they do? Here they chose two. Characters in case of dihybrid cross. That is the shape of the seed and the color of the seed. Okay, Krishu, clear with that? And over there, the phenotypic ratio for dihybrid cross is 9:3:1. Okay, students, you can see over here, whereas this is the genotypic ratio. Is this clear? You will have to cross that. Okay, yes, Krishu, I can aram se find out. Okay, all the best for your exam. I know you will rock the exam. Okay, fine. So, students, this is all about, and sex determination is also very easy. See, it carries XY chromosome, female XX chromosome, right? If the child receives one X chromosome from the mother, one sex chromosome from the mother, and another sex chromosome from the father. If the child receives X from the male, then the child develops into female. In case if it receives Y, then it develops into male, boy. That is all about sex determination. So, students, I just added this flow chart so that it will be easy for you to revise. Okay, there is nothing much in this heredity chapter. Okay, we'll have to know monohybrid cross, dihybrid cross and sex determination. These are the three important topics from where 3 mark, 5 mark question can be asked. Yes, Kalaim, I will explain. Yes, there was feedback mechanism, right? Yeah, feedback mechanism is nothing but, see, I'll give you, see, feedback mechanism, it is a mechanism that regulates the release of hormone. Okay, like you all know, hormone, see, its function is very specific. It is secreted by one organ and its action will be on another part, right? So now what happens is that I told you hypothalamus that will, see, I'll write the flow chart. Hypothalamus, okay, pituitary gland, and then pituitary gland will, let's talk about thyroid gland. I'll give you example of thyroid, okay. Thyroid gland. So now thyroid gland, what does it secrete? It secretes thyroxine. It secretes thyroxine, right? What is thyroxine doing? The thyroxine, it is involved in metabolism of nutrients, carbohydrate, fats, protein and all that. Okay, mention your doubt. I'll just explain this feedback mechanism, student. Listen to this. Which pituitary gland release? Growth hormone. One is growth hormone, trophic hormone, prolactin hormone, vasopressin, oxytocin are the examples, Krishu. You can take vasopressin, oxytocin, growth hormone, trophic hormone. These are the hormones that is released by the, pituitary gland. Okay. Okay. Which gland is necessary for digestion? See, first of all, I told you, pancreas, it acts as both exocrine and endocrine gland. It acts as both exocrine and endocrine gland. It is pancreas because it secretes pancreatic juice. That is behaving like a exocrine. Why? Because it secretes pancreatic juice and the pancreatic juice will have trypsin in it. That trypsin will digest the protein. Okay, Dipanshu Gupta. Ma'am, what is the genetic ratio of dihybrid cross? The genetic ratio of dihybrid cross is, students, see, I have mentioned it over here. Can you see? 1:2. I'll write it down here. 1:2, 2:2, 2:2, 4:2, 2:2, 2:2, 1:1, 1:1. This is the ratio of, that is the ratio of dihybrid cross. Clear, students? You can note down this ratio, students. This is the ratio, genotypic ratio of dihybrid cross. Thank you, Krishu. You are full prepared. You will do physics, chemistry, biology, everything very well. I am 100% sure with that. Anyway, we'll meet in the evening now for paper discussion. Let's discuss that. If physics also, students, you will do well. You'll do well. Just you have studied whatever you have studied. Just when you are writing your answers, once read the questions properly, students. When you're doing that MCQ part, assertion and reasoning, please read the question twice. Read it properly and mark the answer carefully. Okay. Fine. So this is the ratio, students. Did you note down? Okay. So I was explaining feedback mechanism. Right? What is thyroid gland secreting? It is thyroxine, right? It secretes thyroxine. So what is this hypothalamus doing? It regulates the release of hormone, right? Now let's say when the thyroxine is more in our blood, it is too much. That time, anyway, the function is also done. That time we will have to stop. The secretion of thyroxine. So what happens is that hypothalamus, it will stimulate the pituitary gland. Pituitary gland will stimulate the thyroid gland to stop the secretion. How? The thyroid stimulating hormone will be stopped. When the thyroid stimulating hormone, TSH will be stopped. When the TSH is stopped, the thyroid gland will not release thyroxine. Okay, and when the thyroxine is less in the blood, when that is less in the blood, then thyroxine has to be released, right? So that time hypothalamus will stimulate the pituitary gland, then pituitary gland will release the thyroid stimulating hormone. When the thyroid stimulating hormone is released, the thyroid gland will secrete thyroxine. That's how the release of hormone is regulated. This is one of the example that I have given, which I have considered thyroxine over here. You can increase pancreas also. Krishu, is it what do you mean by hormone and endocrine system? Students, hormone is a chemical messenger. Hormone is a chemical messenger. See, in our body, there is nervous system, right? The nerves are, there are nerve cells, right? The nerve cells carries messages, right? It will transmit messages. But the thing is, these nerve cells are not sufficient. It cannot reach, for external response, nerve cell plays important role. Whereas within our body also, the functioning of each and every organ has to be controlled. The functioning has to be controlled, right? If it is too much also, it is harmful for us. If it is too less also, it is harmful for us. So who is controlling and coordinating the functioning of those organs that is present in our body? It is hormones, endocrine system. Okay, endocrine system. The endocrine glands will release hormone, and these hormone will regulate the functions of the other organs that are present in our body. Okay. Yes, Kalai, we'll move on to how do organism reproduce. See, in case of how do organism reproduce, there is sexual reproduction, asexual reproduction. Asexual reproduction, there are certain types. Look at this. Budding, fragmentation, spore formation, regeneration. These are all the types of asexual reproduction. Fission also. What is happening in case of fission? The parent individual, the parent cell, it divides to give new individual. Okay. In case of fission, binary fission, what is happening? In case of binary fission, the parent cell divides into two cells, and the two cells will develop into new individual. Best example, amoeba, binary fission. Whereas multiple fission, what is happening? The cell, it divides into multiple cells, and each cell will be capable of developing into a new individual. That is multiple fission. Okay. And then comes budding. Budding is seen in Hydra and yeast. It is seen in Hydra and yeast. What is happening is that, for example, Hydra, on the parent body, a small bud develops, and that bud will develop when it is still in the plant body itself, parent body itself, and after it matures, then it is broken. It is released from the plant body, and then that tiny bud will develop into new individual. That is budding. The bud-like projection comes out of the cell, comes out of the parent body. It will stay in the parent body until it matures. After it matures, then it will be cut off from the parent body. Example, Hydra and yeast. And fragmentation, in case of fragmentation, the parent body, the cell is cut. It is cut into pieces, and then that each piece is capable of developing into a functional individual. Now, example for fragmentation is Spirogyra. And in your day-to-day life also, you would have seen lizard. What if you cut the tail of the lizard? Again, the tail will grow, right? That is also example for regeneration. Fragmentation is cutting the cell into 2 or 3 pieces, and that piece will develop. Example, Spirogyra. Whereas in case of regeneration, that particular part, instead it develops into functional part. Okay, ma'am, advantages of vegetative propagation and tissue culture advantages, which hormone are necessary for it? Okay, see, vegetative propagation is a type of asexual reproduction that is seen in plant. In case of vegetative propagation, the spores or seed is not involved. Instead, vegetative part of the plant is involved to reproduce new plant. Example, stem, leaf, root. Best example for root is the sweet potato. Example for the stem is ginger. And then example for leaf is, I told you, it develops that bud-like structure at the edge of the leaf, right? That bud-like structure which you have seen in bryophyllum leaf. You see that bud growing at the edge of the leaf. Let's say this is leaf. At the edge there are buds, right? In the biofilm, you saw bryophyllum leaf, you saw that bud will develop into new individual. Okay, the tissue culture is nothing but from the callus. From the plant, a cell is removed which is undifferentiated, that is called as callus, and for that, auxin is important. Auxin and gibberellin are the two important plant hormone that are used in plant tissue culture. Okay, it is auxin, gibberellin, and also cytokinin for the cell division purpose. These are the important hormones. Okay, Krishu, ma'am, okay, what are the role of appendix? Students, now that is not required for your exam. We'll focus on the important one and finish it off. It is getting time for you also, no? So, I explained asexual reproduction. When it comes to, sexual reproduction in human beings, you will have to, you will get questions from this. The structure of male reproductive system and its function. The structure of female reproductive system and its function. See, the male reproductive system, see, it has got scrotum which is present outside the abdominal cavity where the sperms are produced, and then why it is present outside? To maintain the temperature, and also there is testes which secretes testosterone. It plays important role in the development of sexual characteristics in male, right? And then comes vas deferens, which is a long tube. What is it doing? It transfers it helps in transferring the sperm, right, to that urethra. Urethra is the common passage for the urine as well as the sperm, right? And then there are glands, seminal vesicle and prostate gland. What is it doing? It secretes a fluid which will nourish the sperm, and also it is helping in the transportation. Okay, when it comes to female reproductive system, there is ovary, there is fallopian tube or oviduct, and then there is uterus, and then cervix and vagina is there, right? And in case of female, it is ovary secretes estrogen and progesterone. Estrogen plays very important role in menstruation thing. Progesterone plays very important role in during pregnancy. Okay, clear with that, students? Clear with that? Fine. See, you get over secretion of sweat. Your skin turns oily. That is the common change that you see in male and female during puberty. Contraceptive method explained by surgery. Yes, there are two types, students, which you will have to remember. One is vasectomy, which is done in male. Tubectomy in case of female. Vasectomy and tubectomy. Okay, vasectomy is nothing but here the vas deferens is surgically cut in case of male to prevent the transfer of sperm. Whereas in case of female, the oviduct is cut and it is ligated to prevent the fertilization of the egg. Okay, students, those two are the two important surgical methods. Fine. Okay. One second, students. Okay, students, clear with that? Fine. These are the important things which you will have. And also, yes, the fertilization in plants. Fertilization in plants. See, bisexual flower, this is important. The female reproductive organ in plant is, it is, style, style, stigma, style, ovary. Whereas male is pistil. Clear with that? No? Okay, I know, students, now the time is over. You have any doubts, comment in the comment section. I'll clarify your doubts. Final. Because I know now you will all have to start, right? Heredity done. And finally, in the our environment chapter, this is important, which I already explained. The 10% principle is important, which I have already explained. And the bisexual flower, that one concept is left. I'll just tell you now. See, in anther, pollen grains are generated. When anther releases these pollen grains, what happens? The pollen grain will be transferred onto the stigma, right? After it reaches stigma, what happens? The pollen grain, it develops pollen tube. That pollen tube will, it will expand. It passes through the style to reach the ovule that is present in the ovary. After it fuses, the ovule develops into seed, and the ovary develops into what? Fruit. Yes, fertilization is the fusion of male and female gamete, whereas pollination is nothing but that's what transfer of pollen grain into the stigma. Okay, students, clear with that? This is all about, I just quickly revised the topics. There was someone who was asking, right, what is biomagnification? See, it is the concentration of the harmful chemical which increases with every next trophic level in a food chain. This is called as biological magnification. Okay, so the maximum concentration of such chemicals get accumulated in human body as the human occupy the topmost trophic level in the food chain. Okay, students, clear with that? So yeah, I hope I clarified all your doubts and I have quickly summarized the topic. Right? So this is it for the session, students. And all the best, students, all the best for your examination. I know you all will rock the exam. You all will do great. Okay. So yeah, evening we'll meet you all once again for paper discussion. Now all of you get ready, and I know you all will have to start now, right? For your exam. So bye students, bye. Thank you all. Isomes, I guess that is chemistry topic. Students, do ask me biology topics now. Ask me if you have any doubt in biology. Ask me if you have any doubts in biology. Okay, that's it, done. Kalai, I have finished all chapters. I have quickly recapped all the important chapters. All the chapters that is there in biology. I have summarized all. So this is it, students. I'll end the session. Important difference between, quick recap of the topics. I told now, students, again if I recap the topic, it will take another half an hour. Important difference between what, students? So yeah, we are done with this session. Okay, so shall I end the session? Okay, students, so thank you all. And yeah, all the best for your examination. We'll meet you all in the evening. Okay? So, what difference between for bio? What? Shabat, be quick, be quick. Be quick. I'll end the session now. I guess you don't have any doubt. Okay? Okay, students. All the best for your examination and meet you all in the evening.